So first of all, welcome to everybody joining this CyberRange.IT workshop that is part of the ITASEC Italian cybersecurity conference that is held every year, organized by CINI. It is the National Consortium for the Informatics. So we have in the program a 10 minutes welcome that is going to be rather quick. The organizers of these workshops, as you probably know, were myself and Enrico Russo and Gabriele Costa. We put together a few presentations by Italian universities that resulted from a meeting, a local meeting, a national meeting that we had, in which we tried to make a sort of inventory of the activities related to cyber ranges in broad terms in the Italian universities. So we will provide in the second part of the workshop an overview of what is going on in Italy on this topic. But we will start the first session. We have 3 invited talks by very relevant institutions in this field. We will start with Nina Olsen from EXO that will provide us the EXO view of the problem of getting to cyber ranges and cybersecurity training. Then we have Stefano Solari by Leonardo that will provide us with an overview of the activities running in Leonardo. We will have Colonel Davide Manganaro that will provide us an overview of the activities that are running in these topics in the military forces in Italy. And finally, a talk by a company, BV Tech, that is collaborating very actively on this topic, in particular, as far as I know, with the University of Genoa. So please, Nina, the floor is yours. You can start.
Thank you, Franco. Could you give me the control so I can share my screen, please?
Just a minute.
So in the meantime, hello and good morning, everyone. As mentioned already, I'm Nina Olsen. I work for the European Cybersecurity Organization based in Brussels. I hope you've all had a nice Easter. I suspect that most of you are based in Italy, and I hope the weather is better than here, where it is currently snowing. So I hope there'll be a shift in that soon. But I will share now my screen with you for a short presentation. I am actually, quite happy that, can you see my screen?
Yes.
Okay, great.
Perfect, Nina.
Yes. Yeah, so I'm quite happy that I'm the first speaker, because I think that my presentation likely will have a little bit of a different flavor than the other ones today, because my presentation will not be a technical presentation on cyber ranges, because as EXO we of course do not provide cyber ranges nor cyber range enabled services, but rather we're a European organization representing all the European cybersecurity stakeholders and working on building up community activities and initiatives. So I'll be giving you a presentation on us, on what we do, and then of course going more into detail on our activity on the cyber ranges. So EXO was established in 2016. At the time, it was established the purpose of becoming the private counterpart to the European Commission in a contractual public-private partnership on cybersecurity. We set ourselves up at the time to be reflecting that contractual part of the story, while at the same time also looking at being able to look at what we were calling more the industrial policy activities. So we wanted to set ourselves up to be fully fledged, being able to encompass the entire ecosystem in cybersecurity, all the different topics as well. So that's a 4-year contract that then came to an end formally at the end of 2020. Yet we are continuing informally our collaboration with the European Commission And today we are federating and representing both industry players, also national public administrations. We have as members regions, research centers, and academia as well. And today we have around 264 members across 29 countries in Europe. And also via those are connecting to at least 2,000 organizations across Europe. So quite a wide range there in terms of a community. This is a very, very complex looking chart to show you a little bit where the PPP was fitting into the scheme of the different cybersecurity players at the EU level. This is from a report from the European Court of Auditors from a few years ago, but it shows you that we were there well in the mix and also representing, of course, the member states and regions, as I was saying, as well as the private sector and academia. And we will continue to do so over the coming years. So we can say that as we've built up and now going on 5 years, we are really can say we are representing the European cybersecurity community, both public and private. And just to give you an overview actually of our spread of the actual stakeholder categories. So as you can see, we have a very big contingent of RTOs and universities, but certainly also SMEs and large companies especially. But those you see there are all the categories we represent. So really quite all encompassing, as I was saying, in terms of covering the entire ecosystem. Beyond that, beyond our members, of course, we go beyond. We communicate also and collaborate with an external community that is quite vast as well. Here you see the wide array of stakeholders that we collaborate with as well in our daily work. So, of course, we're collaborating with other PPPs, initiatives, and also the European Competence Center pilot projects, also sectoral organization, national bodies, all the institutions and agencies, of course, but also international bodies and non-EU public administrations. We've had collaborations with Japan, US in the past. So EXO, we actually conduct our work across 6 main working groups that you see there. So we have a working group on standardization, certification, and supply chain management, a working group on market deployment and investments, one which is on the vertical applications, the sectoral demand, looking at users and infrastructure resilience. Then we have a working group which is really focusing on the support to SMEs and the collaboration with regions. So we know that the regions in Europe are very strong in cybersecurity. Then we have point to the last one, which is the working group 6, which was from the beginning the de facto PPP working group, which is on the strategic research and innovation agenda, and also the cybersecurity technology. So that's the working group that continues to provide the input to the research and innovation priorities in cybersecurity. Well, working group 5 there in pink, as you see, is the one we're concerned with today. That's our working group on education, training, awareness, and cyber ranges. So this is an overview. The working group 5 works across 3 main pillars of activity to contribute to an increased cybersecurity resilience, competence, and capacity building effort. So that includes, as you see there, education and skills, where we look at things like skills verification, agile mechanisms in lieu of just the standard professional certification approach. We look at model minimum curricula for university curricula, for course designers. We also have a Youth for Cyber initiative where we look at education modules from kids to young adults. And then we have the training and operational part of the story, which concerns more what we're talking about today. So that's everything from looking at the workforce, jobs, and HR side of things, what we need there. Also, of course, the cyber ranges in terms of gathering those competences, capacities together in Europe, and also seeing how we can use those to better develop training and skills in particular, which is what we're mainly concerned with, of course. And then finally, we have the awareness, cyber hygiene, and gender inclusiveness pillar. So here we have our Women for Cyber, started as an initiative. Now it's a fully fledged foundation where we have a lot of work ongoing, a big community outreach and national chapters as well. And then we've also had in the past an ongoing collaboration on awareness campaigns with the institutions and agencies. This is just a map to show you a little bit how we view the schematic of this whole story. So as you can see, the training and operational pillar, that's where we're really looking at the cyber ranges, exercises and trainings. And we concern ourselves with mainly there as target audience, of course, the users, also of the verticals, and of course, the professionals as well, so staff as well in organizations. This is an overview of our objectives for the entire working group for 2021. You see on the left there as well, our current chairs. So actually Almerindo, Graziano and Shaba Virag are also chairs of the sub-working group on cyber ranges. So I work very closely with them on our current activities. But yeah, those objectives there, I won't read from the slide. It's linked to what I mentioned earlier, but just to give you that overview. Now, if we go into the cyber range topic, I think that what happened was when we set up EXO, we, in the early days, shall I say, so that's end of 2016 and 2017, we still needed to understand better what was the cyber range landscape like in Europe. We needed to do a little bit of homework. So we spent that time, that year, 2017, organizing some internal workshops with our members to also get to know them and understand their priorities and their capacities, specific capacities and capabilities when it comes to cyber ranges, to try and understand, okay, what's the landscape like? What are sort of the strategic vision for cyber ranges in Europe going forward, to try and gain this better understanding. And that also led us to start obviously talks with some external entities. And we actually in 2018 had a collaboration, a short collaboration with the European Defence Agency, who at the time had not long since launched their own European Cyber Range Federation project. And so we actually organized with them a 2-day workshop, which was focused around cyber ranges operation and cyber defense exercises. And the idea here was, I mean, we knew that there wasn't going to be like a specific or integrated collaboration as such, because the EDA Cyber Range Federation project is obviously limited to member states and for mainly national defense capabilities, but it was really trying to have a knowledge sharing and best practice sharing between them and between the industry players that we had in EXO, to discuss around the federation concept and also what could be done specifically maybe on that within industry. So the EDA presented their project and we strengthened our collaboration with them very much so, even if, of course, the defense and military aspects, like I said, are not in the scope of what we were doing. And we also realized that the federation and interconnection of ranges was not something that was going to be an EXO priority, nor really in the scope as such of what we could do, since we wouldn't be able to provide the technical platform to really affect that with all of our members. But it served well as a good opportunity for our members to really share their solutions. And there was a special attention also to the solutions related to technologies capable of integrating existing cyber ranges into more complex simulations. So I think that there was a lot of good knowledge sharing that came out of that, and I know that there's also some specific opportunities that arose for EXO members. Then we moved to 2019, where that's when we started really our concrete collaboration with the European Competence Center pilot projects. So that's Concordia, ECHO, CyberSec for Europe, and Sparta. And these are the 4 pilot projects that have been funded by the European Commission to kind of set the scene, build up the groundwork for what is to become the European Competence Center for Cybersecurity. And so we work very closely with them, and we started a collaboration with them also on the CyberRange topic, but looking specifically into simulation-based competence development. And so we actually launched a study with them to try to really understand how organizations in Europe were addressing competence development through CyberRange exercises, and to see how possibly as EXO, as industry, we could deliver solutions that would better fit their needs. We had at the time quite a limited number of respondents, I should say, though, of course, also the survey wasn't online very long, and that was on purpose. We wanted to move quickly. But we had a little bit limited number of responses, but yet with very different backgrounds and organization size, and also from different countries, which was good. And we had a number of outcomes or results coming from that. Of course, everyone was categorizing cybersecurity as very important, but we also saw that there were a lot of gaps when it came to organizational capabilities, awareness, and also just employees' skills and just regular cyber hygiene as well. And also we saw that preparation and mitigation to cyber events were actually quite low. And that very few actually had the financial vehicles such as insurance to manage that. And there's a number of other outcomes from that, and the survey is public. The survey report, sorry, I should say, is publicly available on our website. There's a link there if you want to check it out. But it certainly served to teach us a lot of things about what were some of the gaps out there. But I think what it also taught us was that it seemed like there was still not enough understanding, comprehension, and communication around cyber ranges in Europe. It seemed like a topic that was not well understood unless you're really working with it every day. This was probably also the reason why we got fewer responses to the survey. We realized even the European Commission people were telling us we don't really know what a cyber range is, what it can do. So we realized, okay, there's a gap here, and first and foremost, maybe we should, as EXO, try and communicate in an understandable way to the entire community about, okay, this is what we understand cyber ranges to be, and this is what they can be used for. So that's what we did. And so we released a paper in March of last year called Understanding Cyber Ranges from Hype to Reality, which really, like I said, the outline really is trying to define what a cyber range is and what it can be used for. So the different use cases, everything from, security testing, research, competence building, recruitment, competition, and so on. Then also it looks at the different cyber range functionalities and capabilities that we see, the different cyber range technologies, so conventional versus cloud virtualization, also the inter-cyber range communication. So again, going into this federation of cyber ranges versus integration of ranges discussion. And then also the delivery models. Cyber range as a service or on-premise. And I would strongly encourage you to have a look at this paper if you haven't already. We're very proud of it. It's been widely shared and is today actually widely referenced by scholars, cyber range providers, the European institutions, and also the 4 pilot projects. We also offer a definition, our definition of a cyber range in that paper, but it's a little bit long, lengthy, so I didn't want to put it here too. I will let you have a look, but that definition has also been taken up, and so I hope it will be useful for you as well as a resource. Sorry. So moving on, where we are today. Well, with all these activities that we've done, we've learned more about, like I said, the actual community that we have out there, the understanding of cyber ranges, the capacities that there are in cyber ranges, and also, of course, some of the main needs that exist with regards to, do people want to go into federation? Do people want to simply have a network of collaboration, a kind of market platform where they can work together? We, like I said earlier, we are not focusing as such as a project on federation, not least because I said, we don't yet have that capability, but also there are others who are doing this already, not just EDA, but the pilot projects are looking into federation. But rather what fits us better is to actually look at, again, bringing together this community and actually looking at developing the European CyberRange market and services as a whole under the EXO umbrella. And so that's what we want to do, and we're actually finalizing these days a call to action. So this will be released very soon, and so keep an eye out for it. It's a call to action that will be published on our various channels. It will be public, and the idea here is really for us to gather and showcase the different European cyber ranges, but also CyberRange-enabled services that are out there, to really gain a better understanding of the market in terms of those use cases, functionalities, and capabilities, so that we can also move to actually better meeting market demands and expectations. The way we see this approach is actually going over two phases. So going from a call to action and going to something a little bit more possibly operational as a network. As a first phase, this call to action is really looking into consolidating the community. So we want to gather the community to link those providers and end users and try to optimize the procurement of CyberRange-enabled services. And we also want to organize, and this is what we'll be doing first of all, once the call to action has been out there a bit, is to organize workshops targeting specific interest groups. So we want to understand actually for specific groups, what are their most important needs and use cases when it comes to the cyber ranges. And that will allow us then to identify some baseline functionalities and actually develop some best practices in choosing and acquiring a CyberRange and range-enabled service for those interest groups. And our hope is that if we do that for these different groups, and I should say, by the way, the first workshop will be targeting academia. I think we have quite a lot of university representatives here today, so please do keep an eye out on it. If you're interested, we'd love to have you there. But the idea here is once we have those, and I think we're targeting probably 4 interest groups before September. So academia, HR, large companies, and government, that we can identify all these baseline functionalities and best practices and put it into a document that could serve as like, yeah, a best practice and procurement guide of sorts that hopefully would be a useful tool for the community. And so if we see that with the call to action, with the workshops, that we're building up, that there's an appetite from the community, and there's enough interest, and of course also resources, then in a second phase, we would look more towards the sustainability approach, where of course we would also work with the pilot projects to see how to work with them and what they're doing on cyber ranges, and to actually build it up into more of a network and alliance of sorts, where we can really bring this together in a coherent manner, and where under such an alliance we could offer very specific services to the members, which would be things like a catalog of range providers to assist in the selection of cyber ranges, something like a European cyber range radar, and then also something like developing cyber range evaluation criteria, and actually providing better that link between end users and providers via a cyber range brokerage platform, and other things as well. It could be market studies, could be a number of things also based on the priorities of the community. So that's what we're working on at the moment. Like I said, the call to action is going to be out very soon. The idea here is it's open to the community. We want to hear from the community what they think about this. There's an opportunity also with that call to action to actually endorse and send an application and say, okay, I'm an end user and I'm interested in following this approach and I'm interested in this, and or you can indicate yourself as a provider, as a supplier or service provider of range services, and say, I'm also interested, and actually do a little survey so that we can understand what are the main components of the services that you offer. So everything will depend on the community and depend on how we how they react to this call to action. But I think that there's appetite there, and I think it'll certainly also help to have these workshops so that we can build up the critical mass as well. So I would hope that many of you would be interested in this and would join us in this endeavor. And that's a little bit on the CyberRange story, what we're doing at the moment. So as you see, not a technical presentation, but really a community part of the story, but one where we really hope that a lot of you will join, and also, of course, as members, because that's a way to get directly involved in these activities and actually have a say in how we build up these approaches. But this is just to show you that now, looking forward to tomorrow, to the future, we're still going on, but we have established ourselves, like I said, to really be the European organization to federate and structure and facilitate the engagement of the entire European cybersecurity stakeholder community over a number of important issues. And we really believe that we're also the place to really have these discussions around strategic priorities in cybersecurity, to do networking, and certainly also to collaborate between the public and private stakeholders. So we're going to continue this. We're going to continue our public-private approach, our collaboration, and continue our work, further build up of our approaches, surely more ambitious than ever. And I do hope that many of you would join us, because of course, like I said, being an EXO member also allows you to get directly stuck in and to have your say, and to also boost your visibility and gain access to funding and a number of other things. So that's a little bit my presentation. You have my contact details here on the slide. I will share these with Franco and colleagues, so they can be shared after the workshop. But that's a little bit it from my side. I'm of course happy to take any questions.
Thank you very much, Nina. If there are questions, this is the right time. It was very interesting and informative presentation. I think one of the outcome of this workshop would be to sort of better coordinate the Italian efforts. So I'm sure that we'll be able to somehow contribute to your efforts as well, with the quite strong proposals.
That would be great. I can't see the chat myself because I'm sharing my screen, but please let me know if there are any questions.
Don't see any question.
That either means I was very, very clear, or
well, I think the message was very clear, so it was not technical, so that's probably the reasons.
Yeah, probably.
The reason we don't have specific question on that. So, Nina, thanks a lot.
Well, thanks to you for the invitation, Franco and colleagues, and I look forward to following the rest of the workshop. And I wish you all a nice day.
Also, thanks to being sharp in time. We move forward to the next talk. Lieutenant Colonel Davide Manganaro will give us now a talk. He's from the Joint Command for Network Operations, and will give us a talk on military training, cyber ranges, and exercises. Colonel, please.
So, thank you. Good morning, everyone. Could you just please give me the possibility to show the presentation?
You're enabled. You're enabled.
Okay, you can share the screen.
Okay.
Perfect, we can see it.
Okay, so perfect. So first of all, let me introduce myself. I'm Lieutenant Colonel Davide Manganaro. I'm section leader exercises in the Cyber Operation Department inside the Italian Joint Command for Network Operation. This command just was born about 1 year ago, and was just from the synergy of two different commands, the Joint Command for Cyber Operations and a command C4 command. And both of them, basically, they are comprehensively taking into consideration the various aspects related to cyber aspects inside the military. So both the operational side and, of course, the technical side, cyber defense, and ICT services and networks. Basically, I will put just a few slides to define our training and cyber range idea in terms of military commands, And I will focus a bit more on cyber exercises because I think mainly all the presentation will be about CyberRange. I'll try to define the importance of CyberRange used to perform cyber exercises. Of course, I'm talking about cyber exercises that are actually followed by military people, so inside the Ministry of Defense and our command. So basically, we have initially the need, and we had the need to define specific skill and qualification for our personnel. I will not go deep inside this specification and qualification. We have, of course, defined specific training paths for our personnel according to their specialization and role inside our cyber capabilities. But I will lightly tread on training education and talk about the CyberRange project, the military CyberRange project, and then about exercise we are actually following, and in case just coordinating and ranging from the national side. So basically, we started with this new project, started in 2019, and called UNAVOX. It was, and it still is, a collaboration in the military and industry and academia. And this R&D project is just about to complete its first phase, and it is the conclusion of the R&D project in this year. It's initial operating capabilities, as we call it, in terms of gap filling any eventual needs from the operational side, from the military, and there we will be and reach a full operation capability in 2024 according to more specific needs from the military side. Actually, this range will be stationed in the military TLC school in Chiavari, Genova, and basically, in its final operation capability, it would be able to provide a core environment, extensible and usable from other location, and we will use it, but not just, let's say, the military side. Of course, this is related to military requirements, but it's basically a national cyber range, and will comprise the possibility to deploy courses, to deploy personnel, different teams that take parts in different exercises, and of course also external bodies and universities. These capabilities is associated to the possibility to deploy several theaters and operational scenarios. In this case, when we talk about scenarios, because in the military side, we define scenarios in a different matter, but we are talking about scenarios related to various types of kind of security. So in terms of theater, we talk about different types of information technology that could be used, operational technology, that is basically our concern in terms of military interest, but also in terms of scenarios, this final operation capability will be enable us to basically work and operates on different levels in terms of host security, network security, web, cloud, mobile, and of course, ECS SCADA security. That is basically one of the topics that is actually, let's say, a bit of most interesting for us, because we are talking about critical infrastructure that actually, of course, in terms of military interest is related to external and theater operation, because of course, as you know, in national infrastructure and critical infrastructure is actually a bit protected by national government entities. So we are talking about the CNIPIC in the specific. But let's say our operator will be let's say, skilled also in defending this kind of critical system, because also according to, let's say, NATO policies related to rapid reaction team, we could be called to perform defense even on host nation and abroad. And so we should be able also to provide this kind of expertise and defense to any host nation request about this critical infrastructure. So basically, just one slide in terms of the innovative tech content related to the CyberRange, the UNAVOX project. So we are talking about, of course, a visual modular design. We are talking about the possibility to define, insert specific vulnerabilities through the usage of high-level languages. As I told before, we have the possibility to use dynamic theater. So this means the possibility to provide theater infrastructure evolving there in practice, possibility of creating complex hybrid theaters scenarios. And one aspect that is very important also for us is just checking the evaluation of the performance. So online evaluation as automatic as possible, even if of course, it's not always possible to have a complete automatic evaluation because there are several components that comprise the clear evaluation for performance of a specific team. The possibility to create personal or class theaters, of course, and last but not least, the possibility to interoperate with other ranges. In the specific, of course, we are talking, but also the previous panelists talk about the fact that Italian Ministry of Defense participate to the EDA CyberRange Federation project group. It is one very important project, and we are fully committed about it. And the first slide in terms that describe the cyber exercises basically defines how these CyberRange should be used, because they are just a fundamental component of any main exercise that we are following in terms of Ministry of Defense. As you can see, we are quite involved in several exercises. In this slide, you can see the main ones. And basically, we are interested in all level of cyber exercises, basically being operational command. Our focus is in the technical, tactical, and operative level, but there are several exercises that are touching on. We want to point also to a strategical part. So our, let's say, one of the basic three main events that we are following as a national component of the exercise are the Cyber Coalition, that is the NATO, say, flagship exercise that was born about, it was focused about international cooperation between NATO nations, of course, and that started from this kind of focus and expanded in the last years also with NATO operational components and development also of national cyber operational center that will be connected inside the NATO force structure and will be part, a very important part of cyber leads about cyber crisis, international cyber crisis. The Center of Excellence, so the Comprehensive Cyber Defense Center of Excellence in Tallinn, Estonia, will organize, actually organized every year, 3 different events. 2 different events in particular is the Locket Shield, that is, let's say, one of the biggest events in terms of red and blue play. And I will have a bit of more focus on the next slides about it, and the Crossed Sword. So also in that case, we have a multinational, even if the center is a NATO center, but let's say all the participants are basically the sponsoring nation of the center. So we have about 24 nations, in this case, participation in the Locket Shield. And then, of course, we have, apart from the national support, so of course the component, the cyber component of several major national exercises, like Joint Star or Noce Scura, we will also participate in important events related to cyber defense and cyber operational concerns and exercise also in Europe. So will lend support to the integrated resolve exercise, but also we will participate as part of the national components, the military one in this case, of course, in the Cyber Europe, and very recently in the European MIL-CERT interoperability conference. So let's say there are various conferences, various cyber exercises that basically we participate, or in some case arrange or coordinate for the national participation, and we try, let's say, to exploit and to participate in all levels and all different kind of participation when we are joining exercise or arranging exercise. The next slides focus basically on the lock and chill exercise. That is an exercise that takes place just next week. We are fully committed actually in it, and is an exercise that I think one of the major, if not the biggest one in terms of live fire event that takes place in 2 days. And we have an international cooperation scenario, basically very similar to other exercises, but in this case the scenario is quite original. And we will have and arrange a team organization that in this case is quite complex, because you can see the CyberRange itself. It's quite complex. It was composed of different systems, not just regular one, usually the networks or Windows or Linux system, whatever, but it takes also into consideration, and we will play also on air defense system. We talk about power management, we talk about water treatment plan, and so on. So this means that we will use, and of course, in this case, we are talking about this year because of the actual pandemic. We did not invite, as we usually do, and we did in the past, a lot of our, let's say, reference in the national field in terms of governmental entities or university or research center and whatever, because of course we have a limited manning. So this means because of the pandemic, we basically this year we organized an event that takes place here in our command. It comprises of 54 experts that are on the operational, technical, legal, and also public information side, that are almost always taking place and participating from the command, but it's actually personnel of the command. So and with a few exceptions from the armed forces. This constitutes a blue team. Actually, there are about 24 blue team for this year, and the red team is comprised of personnel and experts from the CCD COE plus international participation. And this big exercise, of course, is basically our inspiration in the organization and the concept about a very also quite close cyber exercise that in this case is organized internally, and is basically an Italian event that will take place next May in collaboration with the under the UNAVOX project participants, and taking place for a classic NATO East Eurasia scenario. We'll focus again in a red team versus a blue team play, even if being a first national event will be limited in terms of number. And at the moment, we're talking about a concept is not yet defined, but will take place on different teams. The red one basically that will focus on an initial recon or catch the flag exercise, and then on the second day about cyber effect to be provided on the scenario, the operational scenario. And blue team that will have the place and the role in the first day about monitoring investigation in terms of a kind of honeypotting, let's say, possibility and honeypotting performance. And the second day, there will be a more active defense, and the blue team will be able to perform hardening or patching on the system. So this basically will will test the R&D project conclusion and will provide us with a first clear idea about the potentiality of the tool that is, as I already said, an essential tool in not just in terms of training, but also in defining and validating concepts and validating skills and checking the competence of our personnel. But it's also, let's say, a platform that is quite needed in terms of a mandatory way, just to provide kind of a battleground for specific personnel, subject matter expert, to interact and to basically check their competence and this event, in our hope and our ambitions, we will grow year after year so that we can possibly could in the future provide more feature and even a bigger event just on the premises and idea already explained and defined associated with the locket shield exercise. So basically this concludes my presentation. So I'm open to any question, and in case you have a further question in the future, you can also reach me through the organization of the event, and we can get in contact and I will provide any other clarification needed or any other information if the case. Thank you.
Thank you very much, Lieutenant Colonel. Was also very interesting presentation. If you have any question or information, so if you don't have any question, I think we can move forward again.
Yes, sorry, Franco. I posted a question. I posted a question because there is a guy that wrote to me erroneously, but I posted in the chat to everyone. Okay, Michelangelo Schillante asked one question for curiosity: Can the red team do whatever they want to catch the flag, or they have limitations? This is the question.
Okay, so theoretically speaking, that there are no limitations, of course. What the red team actually does is just to use and exploit the vulnerabilities that are just in the system. Basically, every cyber defense or offensive exercise is basically defined by CyberRange that already has inside. We are talking also about the locket shield, but any other exercise that usually has already some vulnerabilities inside the machine. So the number of the machine is actually very high, so it's not easy for the blue team to understand and patch and whatever all the vulnerabilities immediately. And so this will leave kind of open door to the red team. So what the red team does in every exercise, not just the locket sheet, but also the one that we are to do in our cyber effort week, is that they basically will use and exploit the vulnerabilities of the system. But of course, if they find any other vulnerability that is not just embedded in the system, but perhaps it's just they find it everywhere on the internet, they can use it. So basically, to answer the question, there will be no specific limitation about it. The only, let's say, concern they should have is just to not use kind of quite destructive red teaming effects that could basically shut down or services or machines that are needed for the play. So in that case, they will have to they will ask a revert of the machine, selective or whatever. But apart from that, so this kind of disruptive actions, they are basically not limited in anything in terms of usage of tools, either proprietary tools or whatever. I hope this answers your question.
I would say yes. Thank you very much again. So let's move forward to the next talk.
I don't know if, sorry, Franco, there are other questions. I don't know if you maybe in the chat, you have to look at the chat.
No, because, okay, now I see that because they were hidden by the other part. Sorry. Okay. So there is another question. Are these tests just for participants belonging to the army or for also for external consultant?
As I told, there are different exercises that basically kind of encourage the participation of military only people or even external and civilian experts. I'd say that most of the exercises we are participating in are not limited to military, but sometimes when we're talking about military operation and whatever, so this is an inside, let's say, limitation of the exercise. Basically, the bigger ones, I'd say, they do not present specific limitation for the external personnel. And in fact, we are in contact, as I told you already, with several universities. We engage and participated together in some exercises with governmental entities and whatever. So basically, I'd say that most of the time there are no limitation in terms of participation of the civilian experts inside the exercise we actually coordinate from the national side. The first example is just the Local Shield, but also the NATO Cyber Coalition is another example of very big exercise that will allow and encourage the participation of civilian experts. So I think this. I hope this answers the question. It's clear that if there's specific interest from the civilian side, apart from our, let's say, usual collaborators that we are in contact with, there's no problem for us in just checking and any interest and eventually provide possibility to participate to these big events. You can reach the Italian Ministry of Defense, and you can reach specifically the various headquarters, and even directly if you want the center. There's an admiral here that is basically our cyber commander in terms of military terms, and you can even reach him and provide him with any request, suggestion in terms of participation to any event, of course, especially the exercises. And usually there's no big problem about it, except for terms of numbers. Of course, we have sometimes a limitation. I'm not talking about pandemic, of course, but we have several limitations in terms also of seats. But apart from that, there's quite, let's say, an open door policy about these events. They are not military events. They are arranged by military because there's usually an operational that is simulated, a military operation, but they are open also, of course, to the civilian world. No problem about it. So I hope this answered the question. Okay. I see there's another question. Hello, are there capabilities to provide exercises in the CyberRange taking time into account, like limitation of time or time within to solve some stressing situation or exercise? Yes, it is. That there's always there are always limitations in terms of the challenges that are faced by our experts, and basically any exercise it's limited in terms of execution time, usually a couple of days or 3 days. But then every single let's say we call it inject, so any let's say, anything happening basically should be solved in a very efficient way to be able to provide indication operational side, but also on the cyber defense side to our experts. So this means that sometimes these limitations are very strict. We have quite not very a long time to solve some, I don't know, forensic challenge or whatever. Sometimes we, our personal skilled personnel should understand any threat in a very specific time in terms of providing this information to operational level, and in case of, for example, cyber coalition, just to use several tools to share the information. We use the MISPES, or it's a kind of platform to share information about malware to other nations in terms of collaboration. So the short answer to the question is, of course, yes, there are a specific time to solve the various challenges, and this time usually are very stressing for the person, because basically this is the aim of the exercise.
Okay, so thanks again. If we don't have any further question, we go to the talk by Stefano Solari from Leonardo. It is going to talk about immersive cyber training and cyber evaluation of technology and processes. So Stefano, please, the floor is yours.
Yes, Gianluca, thank you very much. So if you could get me the control, well, very good. So let me just check if we have a good capability of seeing my presentation and also my face, because I'm in a wireless connection. So I hope everything
we can see the presentation well. We can see the presentation well, Stefano. Please.
Very good, very good. So okay, I will hold in English the presentation of our topic. So I think that the first two presentations were really stimulating and even synergic to what I will say. Of course, Leonardo is a huge company and has a view of the market, and how I will try to make everyone a little bit more aware about how the CyberRange platform of Leonardo in general germinated from important experience that were already I think illustrated. Leonardo has a good engagement in EXO, and of course has a good relationship with the Ministry of Defense, and everything was related to the national cybersecurity. So to be very clear, I just mentioned my topic has CyberRange has a, I would say, winning paradigm for two main reasons. The first, most important, is the immersive cyber training, and then I will try to extend and illustrate the relationship with the world of cyber evaluation of technology and processes, because I think this is very interesting, I would say, evolution of the concept itself. Why paradigm, first of all? Well, because it's something really useful to be related to in terms of various needs that can be institutional or market driven. So I would just begin trying to illustrate what, for our perspective, CyberRange is not, or is not sufficient to be, let me say, addressed. So I see CyberRanges that are mentioned like that, but they are just virtualization software. Okay, so CyberRange for us, it's not just a virtualization software. Even virtualization is a very important technology. Then I saw many CyberRanges on the market and in the community, but they have in reality the substantial competence of people who are able to train people, even can script, can customize things, but they are just competencies. And this is not what we, let me say, target as a CyberRange solution. Then we see e-learning. E-learning is very important. It's something that raises awareness and skills of people. But again, this could be part of a CyberRange, but it is not completely exhaustive in terms of what a CyberRange can do and can be. And well, the three above things could be together And it could be even gamified a little bit, I mean, to make them more interesting in terms of appealing, emotional approach. But again, this is not a CyberRange from our perspective, okay? So the range itself, like the word says, and like the Lieutenant Colonel Manganaro, I think, explained very well in his presentation, is basically what we call polygonal, or something that is related to an exercise, virtual synthetic exercise, and metaphor of a battlefield. Okay, that's where let me say, the word comes from our perspective. But again, what we tend to think it about is a sort of ecosystem, a technology ecosystem, and that Leonardo tried to see as an open ecosystem. And we can witness the really good importance of research activity and the convergence between research and in the industry in germinating good solutions for institutions, for market, and for raising awareness in the cybersecurity domain. Okay, so what is for us? It is basically an ecosystem with high potential. The potential erogates from different directions. So we saw by Nina in the first part of this seminar, the professionalization and the capability to learn that is so important in the community. And that's for sure something that the CyberRange can really address. Then we have an organizational capability to build processes and to enforce processes in huge organizations. So we can say a CyberRange responds to the really demand of resilience, organizational resilience in terms of defense. And I just put here two examples. With a range, you can make blue teams or to cooperate together. They could be aimed to different areas of the it is, of course, a NIST terminology that I just put here to say that you can organize exercises where there are different aims, different objectives for different sub-teams. They all could cooperate together to counter mitigate effects and learn how to defend a complex infrastructure, complex enterprises. Again, you can test and train escalation procedure and communication with the SOC professional, incident responders, and even authorities that try to like CERTs, for example, that try to make information available and threat intelligence information share between different actors. So the communication escalation procedure can really be tested very well with a CyberRange solution. Then again, well, you have even to face technical and implementation of threats. So you can study really the threats, new emerging threats, and you can professionalize people over tools, defense tools, because you know very well defense tools comes together and evolve according to the threats that are basically emerging. Okay. And we know very well the supply chain attention that recently had, and even the different, let me say, evolution of tools toward that direction. Again, evaluation of people, evaluation of processes. I would say even automatic evaluation of people and processes. This is the research area, very, very important. The universities that will be attending after are very, very aware of the importance of such a research area, and the CyberRange is a good, very, very good occasion and environment to test even those kind of new algorithms and approaches. And then again, automation. I would say that to train effectively, huge number of people, you need to automate the threats realization in your systems. And that's why something we, as Leonardo, put so many attention in the evolution of our platform. Again, repeatability. I mean, the real important things in terms of efficiency and cost is that you can set up exercises and you have to repeat those exercises. It is not so spread the attention that should be deserved to the design and reuse of theaters. We come from experience in the participation and even support to military exercises or even huge organization of exercises where the cyber theaters to be built took so long, and so they are so costly to be built and to be prepared with all their vulnerabilities that need to be accurately planned. Well, even the repeatability of things, it is very important in order to cut down the cost, basically, of the preparation of each scenario, and even to have a broader and broader audience to your exercises. And again, what I call here a little bit, stimulating the attention, quasi-repeatability, I mean to say almost repeatability, because when you prepare an exercise, you really need to change something from a session to another. Otherwise, things like I would say passwords, keys, everything is related to the real vulnerability details should be changed. Otherwise, of course, the scenario could become old from a session to another. Okay, so even the capability of the system to regenerate some scenario, but even modifying something about that is very important from our perspective. Okay, so let me just change slide. I have some problem here, technical, but okay. So what are basically I would say the process that we run through when we we had in mind to design the requirements of our CyberRange platform. So we put attention, as I said, to the design of things. So the capability to have a sort of directory or library where you can put components and you can design the interrelationship between components to generate even new and unexpected situation on which the teams could be merged, first of all. Then, of course, you need to focus on the objective, the training objectives you want to get, and then you have probably tools, all the specialistic tools that are needed to realize the threats. So you have to realize the threats. You have to realize automatic tactics, technique, and procedure in order to stimulate the environment properly for your objectives. And then, of course, you can define all the metrics and all the indicators that you want the range to be aware of and to gather in order to make the white teams or the evaluators of the observers of the exercise really aware of what's happening and which is the real context. Of course, this has to be done in the most transparent way for the participants. Okay, that's the real difficulty. I would say technological difficulty of the range of a range. I would say cross-domain range platform. And you have to do it trying to be the most transparent as possible. And when you are not able to be transparent, you need to protect and to monitor what is a sort of visibility residual visibility that the range gives to the team in respect to a very completely realistic and immersive situation. Okay, so which are our key features? So to have a software-defined data center below a CyberRange, first of all. Of course, this is very important. It is needed for scalability and even to offer capability in virtualization and provisioning of components. Then the federability, like Nina underlined so well in the first part of this seminar, federability is very important, and it can be done at different levels. It can be done in terms of deployment capability to other environments, or in terms of receiving deployment commands in order to offer capacity to other part of a federation. It could be a scoring capability to gather data and evaluate situation, because you can have algorithms or metrics that are interesting for some exercises. It can be battlefield federability. I mean, just sharing assets with other assets in a sort of course, virtualized overall scenario that is mapped to different physical systems, and so on. So we put attention to the full automation of the attack campaign, because when you have to train blue team, you need to stimulate the blue team, but you don't have time or resources to have people who are repeating continuously attacks over differences, replicas, for example, for the scenario. So it is very important for our perspective. And we put so many attention in the tools to design the scenarios and the theaters. And to inject information, because even the injection of information during an exercise could be critical for a good, let me say, coupling with the reality of the exercise. Then we need for supervisor and spectators to have a good awareness, of course, of what's happening during the exercise. And we have to provide the remote access, not only because of the, well, challenging situation we are now, so many people couldn't attend or participate just moving themselves in the premises, but also because, of course, this remote access gives also a sort of isolation and segregated isolation of different instances of the theaters. And that's what we require basically to have a multi-exercise and multi-instance CyberRange that is sure, that is safe, that is something that is secure in terms of access and visibility of the different teams. And then, of course, I don't want to say that e-learning is not important. It's very important. The CyberRange can even offer services for e-learning and, of course, situation where you have just to make people experience directly with some machine what they have learned during their courses. So we put attention to the library of components because the CyberRange cannot be exposed to the market or to the institution like something empty, but you need to have contents. And also, of course, it is a little bit more specific topic. We could use the CyberRange together with other tactical systems in the military research to be more effective and powerful in the exercising in specific domains. Okay, so I don't want to go into so much detail, but this is just an overview of the architecture. I would like just to underline the capability that is needed to federate everything, the models that we have in the CyberRange, that we are very interested in trying to expose the CyberRange as a service. So the metaphor by which people can design their own theaters, their own vulnerabilities, they can use their own tools, and they can even try to set up real end-to-end exercises without specific custom development or specific custom intervention by for example, Leonardo or other providers of CyberRange. And then, of course, a particular attention to what is even the physical connectivity or connectivity to virtual platforms already existing that are not necessarily designed from scratch and deployed from scratch by a platform. Okay, so this is just a very, very, let me say, cross-side overview of which are the components that we invested on to make a CyberRange solution. Let me say competitive, but also very useful to everyone who wants to approach that paradigm. Okay, so we are talking about the modeling tools, for example, visual modeling tools to make productive the generation of what we call blueprints, and that are basically descriptions of all the technology that are needed to be generated dynamically in order to make the theater to be able. We invested so much, and this is absolutely even thanks to the research program that was already mentioned in the last presentation, and we had the capability to work with the excellence in the cybersecurity national arena, and that allowed us to define a domain-specific language to generate these theaters that can be part, the target of exercises, and also to visually design those theaters in order to be very productive in their variation and their maintenance. Okay. Then we had so much attention even to the automation of the tactics. So I just put here some example of how we manage, for example, an attack on a SCADA system, just preparing some tactics that can recognize vulnerability on a node, exploitation of nodes of node vulnerability once we have scan a network, and then try to execute locally some command to, for example, for this SCADA user interface. So we devote so much attention in the sort of language that is capable to define tactics, and not only, let me say, just scripting some attack, but trying to connect to the market tools, because of course tools in the cyber offensive and penetration testing domain are really evolving over time. So we prefer to develop connectors to tools that could be open source, they could be commercial tools, but they are really important to generate a good example of malicious traffic and realistic situation. Again, I just underline here the presence in the platform of some more, let me say, elements. For example, elements to generate background traffic that to be very realistic in the exercise. And then, of course, as I said before, we can connect to a plenty of different tools in the cybersecurity domain in order to make every attack really sophisticated and chained. So basically, we are able to cover all the kill chain or the, the categories of the Mitre attack metrics and so on. So we can really generate sophisticated attacks, really realistic, and even have a sort of scheduling and timing for those attacks in order to be realistic, and even to give the time to the defense to react when we choose to make defense blue teams to react. Okay, so the setting for an immersive cyber training is basically always like that. It's a very general approach where we can make all the type of participants to exercise to access. So not only, let me say, the blue team or the red team, but also white team can access to the system and have the visibility of what's going on the theater itself. And then what's under the hood, a little bit under the hood? Well, we make use of a very important use of dynamic deployments, so cloud provisioning technologies. And this allows us to be really segregated and isolated in our generation of exercises. Here you see an example where we, for example, are just depicted all the agents and all the services that we generate and automatically deploy together with the instance itself. So the blue teams, the red teams, even the yellow teams that can simulate users, for example, of the theaters, can see just their own targets, their own enterprise in scale. But the range is something more. It does not only deploy the targets or the defensive tools, it also deploys all the information that is needed to gather events, to make calculation for the scoring purposes of teams, and even to give access to the teams themselves. So the VPN server itself that we use, to access the teams is dynamically deployed in our integrated solution. Okay, so a little bit more focus on the scoring. The scoring is something that come from multiple of sources. We can have scoring gathered from the direct queries that we make on any node of the theater. We can measure availability and usability of services, and we can even gather reporting from teams, because one aspect of evaluation of teams could really be the capability to communicate, to express, and to really detect the most of the threats that are happening during the system. Like in the previous presentation was really clear, is that some metrics could depend over the time needed to resolve some issue or to detect some threats or to make some corrective action. So timing is very important. So we use, of course, an analytics stack to gather all those events and to make all the metrics that are necessary over time. There are basic metrics. There are, of course, a huge of possibility that can be even customized for each type of exercise or training session and so on. And that's basically the architecture that is deployed and constantly and permanent deployed in order to offer the range, what we call range services in terms of capability of managing a theater. Okay, so briefly, domain. We can face the ICT domain. That's the most historical one. We can face a SCADA domain. We can face even the telco domain. We are very interested in having different capability for the telco domain. Telco domain 5G is a very important emerging technology that will affect all our infrastructure. And that's very important that the range is capable, from our perspective, even to manage all the functionality of a core network and even of an access network of 5G technology. So we are very interested in going into the direction to populate our library even with telco components. Okay, so I conclude my presentation with some reflections on the, let me say, capability of the range to be very useful and a winning paradigm even for the world of cyber evaluation and testing. Part of the key features that I already presented were automation, repeatability, and this is something that led us to make a sort of semantic migration of the concept of CyberRange and to extend the concept not only for the training and exercise, that's very, very useful but even for the cyber evaluation and testing. Because when you evaluate some technology from a cybersecurity perspective, you need to automate so many processes, and you even need to repeat and even to reconfigure, but repeat so many times the deployment or the testing. I just make an example for everyone. If you want to set up a fuzzing campaign, for example, for some components, you need to configure the fuzzers, you need to configure it, and it could be a very, very important and time-consuming task. So the repeatability and the parallelism of your testing is very important. So we found that the CyberRange and the CyberRange services that we developed are very, very useful and can be really extended to cover the world of cyber evaluation and cyber testing. So that's basically what I wanted to underline here. And what happens to the tools that we already had deployed and available for training and exercise in the range? Well, those tools are can be really deemed as very valid and very applicable even for cyber evaluation, cyber testing. Even if, of course, some tooling should be specialized, could be extended, but the background and infrastructure that we already set up is demonstrating itself so good even for such kind of domain. So the process you can really, I would say, add to the one that we already have in place is to be able to integrate new components, not for example, only to deploy them for exercises, but even to make what we call wraparound testing. I mean, you can put components in order to make your target evaluation to be, let me say, to interact with all other components in order to keep it operational in the good state to make the testing that you want to perform. For example, you have to select specific tools, of course, because cyber testing is not cyber training, so you need specific tools, but you can orchestrate those tools with the same platform, as I told you before. And then you have to, of course, create your automation of your evaluation. But this can be done with the same components, basically. And then, of course, you can choose which is the type of indicators that you want to take out from your tools and from your targets in order to really evaluate the vulnerabilities that you found. Okay, so that's something really possible. We are doing that, and we are using the same components to measure, not only, for example, to generate traffic, but also to measure the quality of services, the quality of experience, and the usability of something that is under attack. And you can drive important information about that. We can use targets. We can use metrics for network evaluation, and we can use the fuzzing, of course, like one of the primary tools in order to discover new vulnerabilities. And it can be done in a very broad, let me say, spectrum of domain. Thank you very much for the attention. I stop here. I hope to have given to you a flavor of our industrial perspective, and I'm open to any question.
Thank you very much, Stefano, for this very interesting presentation. We have time for a few questions, if any. I actually have a question that is closer to my expertise. You mentioned the wish to integrate telco components into the CyberRange.
Yes,
Does it
absolutely.
mean that the goal is to test, because of course there are many possible different implementations of these components in general. So I guess the goal is most of all to test the effectiveness and the robustness of the protocols rather than the single components. Or you're also interested into the analysis of the single components in their implementation. So looking for bugs or something like that.
Yeah, thank you for the question. Well, yes, we are understanding that for even cyber resiliency evaluation of complex infrastructure like the 5G, for example, core network, we would take benefit in having in our library the capability to deploy even part of the components or the network virtualization function or software-defined network capability. What we really are focusing on is the let me say security requirements that can be mostly specified, for example, by institutions like GSMA, 3GPP, and so on, in order to evaluate the cyber resiliency. So the fuzzing, for example, it's very useful to take the good information about the implementation and the conformance to the specification, to the interface of those components. But we also tend to check even more, let me say, network level configuration, for example, because all the key management of such a part of infrastructure usually is not completely mandatory, and it is not completely defined by the standards. So the range could really have a second life, let me say, not only for training specifically people, but also to automate and to repeat procedure in order to check the correct configurations of those kind of components and even their implementation behavior in terms of conformance and, let me say, robustness to any malformed information that is exchanging. And fortunately, the telco technology is becoming more and more similar to the CyberRange technology because it has adopted, as you perfectly know, all the clouds, related technology, all the software defined, and so on. So we think that is even more natural to address this topic now in the 5G era than in the previous era of the CyberRange direction.
Absolutely, I completely agree about this. Thank you very much.
You're welcome.
So, if there is any other question, if not, I don't see questions on the chat. So thank you again, Stefano. I think we can move forward to the next talk, where Sabino Caporusso by VVTech will talk us about CyberRange and ICS integration.
Hello, good morning, everybody.
Good morning, Sabino. Just a second that we give. Yes, I can hear you well. I think everything was fine.
Okay. I will share presentation. Please let me know if you see it.
It is coming. Okay, we see it. So please,
Okay.
the floor is yours.
Okay. First of all, let me introduce myself. I'm Sabino Caporusso. I'm in charge of the project management of research project our company is running in Puglia, and I will introduce this shortly hereafter. Our company, VVTech. VVTech is an Italian company active in ICT since 2005 and currently has around 1,000 employees and major sites in Italy and also abroad in London and Boston. We work practically in every sector of the ICT, and we are now focusing on cybersecurity. Cybersecurity is a very important item for us. We are investing much in research, and we are proud to be one of the founding partners of the interdisciplinary consortium for improving critical infrastructure cybersecurity with the MIT Sloan School in Boston. which now is the cybersecurity at Miss Loan, or CAMS. The activities and coordinating are part of a funded project by the Puglia region and the European Union that aims at developing a suite of cybersecurity products. As part of this suite, we are developing CyberRange that is now available as a prototype. And in particular, in this area, we are working to integrate advanced support for ICS, for an ICS CyberRange that would be the thing that I will illustrate in this presentation. We had that were important to shape how we approach the ICS issue for CyberRange are the one that we made in other research project, in particular one that was co-funded by the Italian Foreign Affairs Ministry and by the Israel Ministry of Technology. That was aimed at securing, at providing tools and technique to secure the water distribution infrastructure. We worked to develop a secure gateway to protect the communication over remotely managed water pumping station and other element in a water distribution system. And that was important because another part of the project was also related to understanding how those physical measures that can be gathered from the field, from the sensor, from the ICS systems, could be used as indicator of potential attack that maybe the security system could not identify in advance. Another things that really important for us that in making this experience, we also had the possibility to share and to test our experiences in a lab where a small model of a water distribution system was built with tanks, pipes, pumps, valves, and so on. And we were able to gather such experience and also to see what could be done in order to prevent the people at first from moving to be present there in the lab where the scenario was replicated in this model, and then also to be able to create a very complex scenario that could not be replicated in a way using scaled elements. Okay, so these were two important inputs that prompted us to move when we started working on the Cyber Lab also to systems. Industrial control system, effect to the industrial control system is something that you know. I will not go through this, but there are a lot of examples even very, very close to us. And other issue that prompted us to work on this is the CyberRange, a CyberRange for the ICS, just a traditional IT CyberRange plus the ICS devices, or is something different? We think that is something completely different because if we want to have the realistic simulation of what's going on, we have to take into account also what is the physics of the process that the industrial control system is managing. So what's happening in reality in this way, you cannot easily simulate what is really happening, for example, on water distribution network or on power grid, unless you are able to model how this system is this complex system is really working when you are doing your exercise. So we understand that there is the need to be able also to model that part of the exercise. If you want to run an effective CyberRange exercise on ICS. And another issue is that, of course, the OT security, so operational technology, is very different from the IT security. And then there is the need to be able to bring together both the IT people in charge of the security and the OT people in charge of managing the industrial control system, and also, as we will see later, which are sometimes also in charge of managing its security. So in our view, the ICS cyber range are needed to train the operator of the OT to detect and respond to cyber attacks, to train the IT operator that do not have knowledge of often of the ICS equipment protocol, and especially of what is the normal behavior during their operation in order to be able to identify anomalies and potential threat and attack. And most important of all, maybe, to prepare both teams to work together in the events of an attack. Just a quick slide to summarize which are the major difference between IT and OT. This is quite sketchy, but maybe leaves some key information. So the IT, we said, deals with the information, where the OT deals with the machine. The IT manages basically data and their flow, while the OT manages operation of machines and physical processes. The environment are different. So the office data center rather than the factory or the plant. The IT is considered, even if this is not properly correct, software-centric, while the OT is more hardware-centric. The IT is, by its nature, heavily interconnected, so all the systems are heavily interconnected. We have the internet, they need to speak together. The OT joined this only lately, was not born with security in mind because it was air-gapped, but now is increasingly interconnected. It has a short technology, and another big difference from the point of view of security is that the IT has a short technology life cycle compared to the OT, where we see plant and device that manage them and technology that maybe are operational for 20, 30, 40 years and so on, while these life cycle time are not acceptable in the IT environment. And so these affect heavily also the security. So the view from IT perspective, these two worlds are quite different, and also the people that work in these two worlds have a different view. Let's see the OT security from the IT perspective. You see the typical IT paradigm for the security is to guarantee the CIA confidentiality, integrity, and availability. So these are the business priority. First of all, confidentiality and integrity, while the business priority for the OT is the availability. Even if we are trying to map the OT to the CIA paradigm, as I told you before, and we will see that the OT people have a different view. The attack surface is different because are different the kind of devices that are can be subject to such an attack, but these are more and more interconnected. And then, as we see, having the two systems interconnected, the attackers can move from typically an IT network as an initial point of compromise, then move to the OT network. And while the major consequence of a successful attack could be the loss of data in the IT sector and all the impact in terms of economics that could this could result in. On the OT side, we have the physical damage. So the physical damage that could be also an issue of safety, so damage to the person. When we see the what is OT security from the perspective of the OT people, they refuse the CIA paradigm and say that rather it's safety, reliability, and productivity that are the only things that matter. You see here they put safety at first, which is the first rule that is followed when building industrial control system, the safety for the people that is working there and the safety for the infrastructure, for the service and so on. Then they have the reliability and then productivity as well. As we see, there are rather different words and rather different approach, and the OT security expert does not consider as a norm the IT security measures as appropriate, as the IT people do not have a sound understanding of what's going on and how OT operates. So this is another issue because there is a need to put these two teams together to work to understand each other and also to be able to manage the security, because this is a key element. Of course, the complexity of the system has increased in OT through the integration. The attack surface has increased and is more complex to address and analyze all the vulnerabilities because there are more and more interaction between the IT and the OT, and the OT, moreover, is interacting with the physical environment. So this can change very much and could affect how the OT system is behaving. And as we have seen, there is a big language barrier also as well between the two teams, the two worlds, let me say, that don't speak the same language, don't understand each other, and this can result in big problem when there is an attack on the system where both parties have to be involved to counter the attack and to take remediation measures. So there is an urgent need we see to develop tools, techniques, and procedure to enable the two teams to understand and to work together. In the kill chain for the OT, you see that typically what the attacker objective are those of disrupting the process or causing physical damage, and at the end they could endanger even the safety. So the defender objective in the kill chain is to on the other side to ensure continuity, prevent physical damage, and ensure the safety. So quite different from what is the task who is in charge of IT security. As we see from the industrial control system cyber kill chain, we understand that in general, sophisticated cyber attacks are very complex activity, and those require more steps, which usually start in the IT and then move through the AT, through the OT, sorry. So to prevent and to counter such sort of attack that are really could be really sophisticated, there is the need to continuously train in a specific ICS cyber range both the AT and the OT people, as I just said before. What we see as the state of the art in the ICS cyber range, what we see is that normally, even if everybody has an ICS function support in the cyber range or claims so, very often the modeling is limited to only a few targets that are interconnected, and so do not to some SCADA or some other control system, and by their nature do not model the full complexity of the system we are simulating in our CyberRange. So even the type of attack or the effector of the normal behavior of that component under the normal process evolution are not reflected, and so there is no way to teaching to the people who are attending the training what is the normal or expected behavior, and to identify which are those anomalies that could happen, because we can have exceptional situation even during normal operation of an industrial control system, which are not indicator of an indicator of a potential compromise of an attack. Okay, so the physical behavior and the interaction with other elements of an industrial control system are normally not reflected, and in this way the full effects of any action being they malicious or not due to normal operation are not reflected on the SCADA interface for the OT operation, and so they are not trained to manage and to distinguish from a potential attack situation and situation that can occur during normal operation. And moreover, more of them are not really hybrid in the sense that cannot have a component that is connected to CyberRange to be really fed by input and providing output to other components or SCADA system which are consistent with its behavior on the field during normal operation. This is reflected in the fact that on an ICS control system it's difficult to have, and most of the time you don't have a legitimate network traffic on the communication links for the operator to analyze or check, and so it's quite easy to identify anomalies because in some way the ICS is not working with real data coming through. Okay, whether they're coming from the field or from a simulated system, which is the ICS they control. And normally the target audience is those of the IT operator, so the security team, the blue team, and normally does not include the IT-OT joint team. So the OT teams are not involved in such exercises. Supporting this view, it's interesting to see what is reported in the closed report on ITASEC in Italy for the last year, that outlines how the security for ICS system is managed in large Italian companies. We see that it's mainly managed by IT function in 47% of the respondent. In 11% there is an information security function which is not part of the AT. Only 4% of the cases managed by the operation function, but the most frightening thing is that in the 23% of the cases, the management of the OT security is split among two or more functions. This means that for sure there are some gray areas where no one is in charge of managing or assumes that the other part is in charge of managing something. And this is the ideal place for an attacker to pass unnoticed, okay, when if he could exploit such weaknesses. And in 15% is security delegated to any function. So we see that in 38% of the cases, there is not clear who has the ownership, between IT and OT to manage security of the ICS. Then we can discuss whether this function should sit within the IT, within the OT, or within a dedicated IS function. But the frightening thing is this 38%. This is reflected by the fact that then coordination mechanism between IT, security, and OT were defined only in 44% of the organization, which confirms what we just said above. What are the remediations that have been introduced by the organization to improve the security in the ICS system is, as you see, one of the most important things is the fact that they have added segmentation, access control, privilege, etc. in the ICS network and in separation between IT and OT network. And also they have invested heavily in setting up security operations center with advanced technique to manage and control the security. But of course, a key issue remains security on the OT network, and in dealing and be able to coordinate together with the OT people. What is our view following this? We need we think that it's important to have an improved CyberRange in order to be able to provide a joint IT OT security training and knowledge transfer. The two teams need to learn how to operate together with specific instruments they have on their own, and to test the procedure to be used in case of attack. Also, very basic communication procedure, because as we can see, an attack can have on a ICS can have effect on the safety of the people, directly on the safety of the people. And so even if an attack is identified by the IT structure in charge, then that structure should know what are the effects and how to properly communicate in order to inform properly the people that are in charge in the OT of the safety, of managing the safety, which, as we've seen, is the first priority. We think also that improved ICS CyberRange have to be used as permanent as bad, because if we add the physical system modeling capability in the CyberRange, we can model even very complex scenario and industrial and control system, and we can manage all the component integration or just partial component integration to simulate the whole plant, for example, and be able to check how its security can evolve as the threat evolves, and as we add the new technology in the industrial control system. So we can permanently test at a reduced cost through a replica that is fed with the real behavior of the physical system, all these things. So what we did, we did in our research activity integrate a physical system modeling capability within our CyberRange in order to have the effect of external variables of the physical system to be programmed and replicated. We can run different tests with different physical system behavior scenario, and in this way we enable the simulated element or the physical one connected to provide input or receive output to the control system. The physical system itself is able to provide output to the controller or PLC or whatever, receive the inputs, and then all these could be reflected in the behavior of the physical system. And then on the CyberRange side, we can interconnect all these elements, being their virtual or real, to a control station, and we can also see by comparing the behavior of the model from the output that we could see, for example, on a SCADA console, whether whether a sort of attack is able to alter the parameters that the OT operator can monitor through the SCADA console, while in reality the system is going in another direction. Moreover,
excuse me, we are running a little bit late on the program. I would ask you to conclude, please.
Yeah. So, moreover, we are able in this way to add network traffic and communication, which are generated by real inputs on the physical system. Which are the challenges? Predict the system response to malicious action, be able to visualize the effect at the system level, develop a dynamic model for ICS environment. We did this through a joint research with the MIT that I mentioned before, and we have extended our prototype with these advanced system modeling capabilities. Okay, I can skip. We think that these are the main benefits, but I already discussed about this, training both teams, joint operation, and create an advanced test bed for OT cybersecurity. More detail, we have submitted a paper to ITASEC. You will see in the cybersecurity training site. Our colleague will illustrate more in details our activity with all the details. Thank you very much.
Thank you very much for this very interesting presentation. Given we are a little bit late on the program, I would skip the questions. You could reach out our speaker, Stefano Solari, Sabino Caporusso offline, as you can do with all the speakers, of course. The program assumed that we stopped for a little break.
Okay. So good morning, everyone. I am Alessandro Placido-Luise, a cloud architect at the Epsilon Group. I present to you today our research work, which is a service-based platform for the dynamic deployment of CyberRange in the cloud. We will introduce you both to the architecture and the implementation with Amazon Web Services of this architecture. So let's start with the contributions of our work to the current state of the art. We have identified, in our opinion, what are the most important improvement areas today in the CyberRange field. And so these are the requirements of our system. So, for example, the first requirement is environment isolation. We start to the fact that our cloud application will spawn more CyberRanges in the same environment. So environment isolation must be satisfied. Every user must be able to practice hacking within an isolated environment and must not be able to, for example, invade scenarios belonging to other users. The second requirement is remote access management. So the system should be able to perform access control for the registered and logged in users and manage client connections. So the system must make use also of automation mechanisms, so for the configuration of cybersecurity scenarios. So the CyberRange will automatically deploy CyberRange in this virtual world. So the security is another important aspect of our application, of our platform, because malicious users could create resources, illegally create resources, and then So the platform will be able to terminate those resources and to cut the access to users that perform malicious activities, such as invade cyber ranges belonging to other users. So let's move on with the system architecture. So we have identified 4 main components of our architecture. The first one is the CyberRange environment, which is a dynamic deployment environment in which virtual resources reside, so virtual machines and networks. The backend resource manager is a component that creates the CyberRanges within the CyberRange environment. So we have this layer of the architecture that will receive requests from users and then creates entirely new scenarios inside the CyberRange environment. We have also the Credential Manager, so that provides authentication and access control services. So as you can see, CyberRange environment, requirement, environment isolation, backend resource manager, automation, Credential Manager, authentication and access control services, and cluster security controller, security requirements. So the security controller performs checks on the architecture and takes decisions such as resource termination or access policy changes. So let's take a look of the architecture. So we have the user that log in and register to the platform with the Credential Manager. The Credential Manager will respond to the user with a username and password. So the user can use this username and password to connect to the platform and then send requests to the backend resource manager. Those requests will be these requests will be validated by the application program interface with an authorizer. So the authorizer will validate, for example, from a technological perspective, JWT tokens, and then pass the validated requests to the backend resource manager. This layer of the architecture will perform security pre-checks on what are the permissions of the user that makes the request, and then creates the resources inside the CyberRange environment. The backend resource manager will respond to the user with, for example, in case of an OpenVPN server with a certificate file, in general, with an connection method for the user to connect to the remote access controller inside the CyberRange environment. There is another layer of the architecture that is the event listener. The event listener will pass events that are happening in the CyberRange environment in real time. So the cluster security controller will check these events and then will perform security actions such as termination of illegal resources created illegally by a user, or cutting the connection to a user, a malicious user. The entire state of the CyberRange environment, so all the actions performed by the backend resource manager and the cluster security controller will be described and saved in the data storage that contains the global state of the CyberRange environment, so the global state of our entire world of machines. So let's now take a look of what is the CyberRange environment more precisely. So in detail, we will see that, for example, the elements of the CyberRange environment set are divided in multiple subsets. So as we said, the CyberRange environment is a set of virtual worlds, virtual machines also. In our case, virtual machines, but they are virtual worlds. There are some relations between these elements of these sets. For example, there is a reachability relation between a virtual machine and another, or there are, we also consider the presence of containers that are, in case of containers, the relation, for example, is of coexistence with a virtual machine. So in the same virtual machine, there will coexist one or more containers that obviously will communicate with other elements of the CyberRange. So the macro range, for example, this is a macro range, is a set of virtual machines. Those virtual machines are divided into more subsets that are the micro range, the micro ranges. The micro ranges are our scenarios. So there are our real hacking scenarios. So a user will connect to the remote access controller the remote access controller will forward the traffic of the users to the assigned cyber range, and this user cannot escape from this isolated environment. So that are called the micro range, so our hacking scenarios. So let's see, all these thing has been formalized. All these rules within the cyber range environment has been formalized, and the micro ranges have been classified. So we classified micro range, so hacking scenarios within the cyber range environment, into 4 main categories that are virtual micro ranges. So, for example, that are micro ranges composed only by virtual machines, containerized micro ranges, in which there are only one virtual machine that will whose kernel serves as the base of execution of containers. Hybrid systems, so hybrid micro ranges, both full virtualization and OS level virtualization will create the hybrid micro range, and shared micro ranges. So shared micro ranges will an user can access by shared micro ranges can be accessed by several users at the same time in order to simulate red and blue team scenarios. So let's move on our implementation of a containerized micro range. That is Docker Security Background. Docker Security Background is, for example, in our case, is a possible implementation of a containerized micro range. Docker Security Background is a service-based framework for the dynamic deployment of cyber ranges in the cloud. For the dynamic, Docker Security Background is a microservice-based framework for the simulation of Docker of hacking scenarios within Docker containers. So another reproducible hybrid micro range is the following. So we have, for example, users that will access this piece of possible implementation of Docker Security Background. This is another scenario that will be created in our cyber range environment. These scenarios combines OS level virtualization and full virtualization technologies. One is a virtual machine hosting Docker containers, and the other is a set of Windows virtual machines. So in this architecture, OS level virtualization has been introduced in order to emulate kernel space vulnerabilities. So in this architecture, we have the first layer that is these are virtual machine containing Docker containers. And the second layer of the architecture is a Windows environment containing virtual machines hosting Windows. So all these architecture will be recreated inside our cloud architecture. So let's move on what is the implementation of the cyber range environment. The cyber range environment is implemented with Amazon Web Services, so a cloud, in our case, a cloud provider. So all the architecture of cyber range is moved in the cloud, in this case, using Amazon Web Services. But the implementation could be done, for example, also with Google Cloud and other cloud providers. So, for example, in this case, we have a user that has a static private IP address. So this user will connect to the remote access controller that is OpenVPN server. The OpenVPN server will forward the traffic of this user to the assigned micro range. All these rules within the OpenVPN server are defined within for example, in our case, the IP tables firewall. For example, this is an example of our rule defined in the IP tables firewall. So, for example, this rule states that all packets leaving the remote access controller will be forwarded to this IP address that contains a Docker Security Background machine. So this private IP address is routed. The traffic coming from this private IP address that will be assigned by the system automatically will be routed to this private IP address containing a Docker Security Background instance. So this is for traffic routing, but instance separation between virtual machines is achieved through security groups that are virtual firewalls provided by AWS. So we will see also a demonstration of all these architecture later. So let's move on the implementation of, for example, of the backend resource manager. The backend resource manager is implemented with a Lambda function that will perform in order these operations. So the first operation is control, for example, will perform controls of user permissions, as we already said. We'll check resource availability within the CyberRange environment. The Lambda function will even spawn new macro and micro ranges. So we'll even spawn new servers, so new remote access controllers. Example from a performance point of view, because we have the server that will manage a limited number of users, and other users who will register to the platform will be routed to another server. So other than that, the Lambda function will declare firewall rules in the OpenVPN server with the AWS System Manager. So let's move on to the implementation of the Cluster Security Controller and Credential Manager. The Cluster Security Controller is an AWS step function that will receive the events from the Amazon CloudWatch. Then in our case, will act as the event listener. So the event listener will listen to the events in the CyberRange environment, so the AWS VPC, and then pass those events to the Cluster Security Controller. The Cluster Security Controller will, for example, check if the created virtual machine hosting Docker security background or also other scenarios are trial scenarios, for example, by checking these tags. In this case, he will invoke a Lambda function to perform these checks and in the future, other security checks. If this instance is a trial instance, that because AWS calls virtual machines instances, this is the system will wait 30 minutes and then terminate this instance by invoking another Lambda function that fulfills the purpose. So the Credential Manager is implemented with Cognito. This is AWS AWS service that provides authentication and access control services for the users. So this is the main graphical user interface. In this case, a user can send a request to the backend resource manager to create a Docker security background trial instance. So the backend resource manager will respond with OpenVPN certificate file, for example, and the user will use with this OpenVPN certificate file to connect to the virtual machine. Moreover, the backend resource manager will give to the user an SSH key in order to connect directly to the Docker security background virtual machine. Let's move on in the conclusion, but if we have the time, I will show you a brief demo of Docker security background. The conclusions of our work are to deploy comprehensive cyber arenas that are an evolution of the classical cyber ranges. We will provide internet protocols emulation functionality, larger scenarios, and then use simulation of automatic attacks in order to users to, for example, simulate red and green scenarios automatically. So the second requirement is deployment of CyberRange. The second future work is deployment of CyberRange with orchestrators such as AWS CloudFormation of other orchestrators. So we will have this scenario that will be described in the JSON or YAML file, for example, and then the CyberRange environment will be hardened. So if you have we have the time, this is, for example, a Docker security background instance. So from my dashboard, I will request the creation of a virtual machine hosting the Docker security background. In this case, I'm logged in as my user. So the backend manager will respond with the status and the private address of the CyberRange of the virtual machine. So now I will connect with the, my OpenVPN Connect client to the remote access controller. The remote access controller is defined in the Exido instance panel. So this is the remote access controller. Okay, so this is the remote access controller, OpenVPN server, my Docker security ground micro range, and then the newly another Docker security ground micro range, and a newly created virtual machine with my username. So, for example, those are the laboratories available on Docker security background. Laboratories are of different types. For example, we have hacking web application laboratories, ExploitDB, password cracking, and more recently also Wi-Fi hacking laboratories. So, for example, this is a laboratory of hacking web application. This is a vulnerable web application Docker container, for example. So I will start this lab, and then I will open this lab from this IP, the IP address of my Docker security ground instance. Another thing that I wanted to show you is that I will connect to my instance with its private IP address. So, for example, okay, this is the instance that was created. This is a trial instance. This is the instance that was created by me, the user registered to the platform. So this is the graphical user interface. In this case, I sent a request to the backend manager that responded with the certificate file in order to connect to my Docker security background instance. The thing I want to say is that this instance is on a private subnet, so it is not connected.
We have some time constraint. Thank you very much for the additional for the demo. Any question from the audience about this presentation? Any question? So in the meantime, I have a quick question.
Yes.
So did you consider how much your solution can influence yes the total cost of ownership of a CyberRange? And with total cost of ownership, I mean the cost of the personnel for keeping running the infrastructure, for the licenses and so on.
Yes. In this case, for example, we have in the case of Docker security ground virtual machine, we have, for example, created a virtual machine that is a micro Amazon Exido instance. So in this case, the costs are really low. Another thing that we have to study, for example, and this is a matter, this will be a matter of studies, is to find for example, will be understand how to route the traffic to more remote access controllers. So we will have more remote access controllers, so more VPN servers. So we have to choose a suitable Exido instance for those remote access controllers in order to find to see both the performance point of view and then both to the costs of those architectures. But at the moment, the costs are really low, because I can host a Docker security ground or a micro Exido instance. So in this case, yes, this will be considered, however.
Thank you very much. Thank you very much. And so we can move forward to the second presentation. Thank you again, Alessandro.
Thank you.
So the second presentation is from University of Verona, and the authors in this contribution leverage the realism of CyberRange system for creating honeypots. The speaker is Massimo Mero. Massimo.
Hi, Enrico. Thank you.
Hi, Massimo. Okay, so I see your presentation, so I give the floor to you. Thank you very much.
Morning to everybody. Thank you, Enrico. Let me introduce myself. I'm Massimo Mero. I'm professor of computer science in Verona. What I'm telling you is a research project that we just wrote with Marco Lucchese. Marco is a first-year PhD student in Verona, and we are beginners on this field. We are new on this, and we are studying. What I will tell you is a story that is very, somehow is very, has many similarities with the presentation of Sabino Caporusso. The presentation of Sabino was more on the side of CyberRange, and here a bit is more on honeypots. You know, honeypots and CyberRange, they are really close relatives. Just let me tell you just a word how we end up here. I come from formal methods, actually formal methods for concurrent and distributed systems, and more recently I moved on formal methodology for the verification and security analysis of industrial control systems and industrial IoT. Static analysis technique, runtime monitoring, runtime enforcement, and then at the end, of course, we moved to simulation techniques. And that's why we were interested in understanding how is the situation for honeypots for industrial control systems. And we realized that from our point of view, I will give you a brief overview of the literature, that there are still a number of limitations that need to be overcome in order to realize really convincing and effective honeypots for industrial control systems. I will not tell you the story of the presentation of industrial control systems. I thank you, Sabino, for his presentation, because we can. It was really very nice. But the point on that talk was really the point of Caporusso was that the real tricky point in CyberRange and of course in honeypots for industrial control systems is the OT part. You know, that is really the critical and crucial part, because in an industrial control system, the point is not really in stealing data. Well, it may be in the corporate network, it may be also an interesting thing to do, but in those kind of critical systems, you know, there's national interest on that. The point is in taking control of the physical process that is underneath the systems, and not necessarily to destroy it, or not necessarily to create physical damage, but possibly to drive the system in a way that is in the interest of the attacker. You know, maybe a different interest. It's not just a matter of destroying a centrifuge. It may be just a matter of putting a system in a way that is not working properly and it get out of the market because they're not producing within a certain, within a certain cost. So the focus here in this talk is about how to simulate and how to write good honeypots for industrial control system, while the focus is really on the OT part. So on the network of PLCs, they are governing physical process, governing, reading sensor and writing command on actuators in order to govern a physical process and to in a way that is written in a program on this PLC. Usually there are different way of doing this. Normally it's done in ladder logic. Well, so the PLC, they really represent the critical point. The most effective attacks to industrial control system, malware. At the end, of course, as a couple Russo said, attacking an industrial control system is a complicated process. There are several stages, but at the end, the goal is to arrive to the OT port and to do some injection on PLC in order to take control of it. And of course, there are several big names, from Stuxnet, it's historical to Triton in petrochemical, to the attacks to the power grid, Ukrainian power grid, Overcrush, Black Energy, and so on. So we were we're interested in understanding how you can decide a good honeypot, to understand those kind of attacks and attack possibly, because when you have a good honeypot working properly and deceiving the attacker is also a good intrusion detection system. And so we realized that most implementation, there are quite a number of implementation of honeypots that are trying to achieve this goal, but they have a number of implementation in terms of extensibility of, in order to deal with hundreds of PLC device. Interaction with the, there are ICS native protocol, Modbus, DNP3, and so on. And then the point, of course, for honeypot, the point is to collect malware, and possibly, and even harder, as Russo said, the real point, the real tricky point is in order to simulate the physical process, in order to give to the attacker a convincing physical reaction of what is going on. Because, if the attacker tries something, to move a heater, and the reaction is just instantaneous, the attacker doesn't get convinced that there is a heater there. So our goal is to design an architectural framework to overcome such a limits. And just tell you just a bit really quick history about all the honeypots that are around. At the end, you will see a list of it, but just, Compot is one of the most famous one, and the low interactive, that is a bit, so it doesn't allow you to have really an interaction, but it's quite, it's very famous. Was used from the US military and many university of American university, and it allows to simulate complex infrastructures. It allows you to have a human-machine interface. This is another, it is an extra attack surface in this kind of systems. And it allows you to simulate a kind of response time to physical interaction with the process. But, it's just a matter of putting a number there. So, I'm increasing the heating, the temperature of my heater, and it tried to give a number, a delay, and then at some point when you test the temperature, you test this. So this can be done in sample physical process, but when the physical process become more complicated, it's not just a matter of putting a delay there. It's a more complicated thing. It's a matter of simulating a physical process. In physical process, they are represented by differential equations. So, and in Compot, the critical point is that the simulation of the physics is really missing. Onify was another interesting idea because they didn't give an implementation, but they basically gave a proof of concept of how to build up honeypot for industrial control systems, where there is a full account of physical process. And so that means, an interaction, a module that takes care of physical process simulation, okay? And of course, also an internet interface, because of course, there's a PLC, as Russo said, many of them, they are exposed on the internet, and you can find them on Shodan, and you can look for them, and you can do scanning on them. And basically what the first thing the attacker does is just scanning of using a tool like Nmap or other tools. So of course you need an internet interface in order to at least to look like a PLC or a battery of PLCs. And then they have a process model, and in order they consider to have a process model. They don't have an implementation. And then they have a device model that they take care of the interaction between the cyber and the physical process. At the end, actually, we started the story. We started from this paper. This is a quite recent paper, appeared in the SCM CCS of 2020, and it's one of the biggest conferences in security. And we started our history of reading this paper and building up the story of and this, I think, is one of the most up-to-date work on a honeypot for PLC at the end. Basically, what they do, they use a honeypot virtualizer, a quite nice work by Provost. It's called ONID. Actually, there is also is a 12 years old, 13 years old work, and still use it. Actually, there is a version ONID Plus by the U.S. Air Force. They are quite interesting, and they are quite using massively for honeypots I suppose in the military, of course, domain. What this tool does, this honey PLC, basically, you see there is, I took this graph from the paper. Basically, what they can do, they can simulate quite a different bunch of different PLCs. You see honey PLC just at the end of this line. How they do that? Well, they wrote down a profile tool. So you give the specification of the PLC, and this profile tool build up a profile for the virtualizer NAD. And then there's a NAD virtualizer that take care of responding to the attacker, just taking the personalization from the profile that you just generate. Actually, this is not really an automatic process. There's some fixing it. And another thing they claim actually is they at the end they do this comparison with. You see, there are quite a number of work. I just mentioned a couple of them. Well, the main thing they mention is they can do ladder logic capture. Ladder logic, just to tell you, is the code running on PLC. Is the user program. Actually, what they do, they don't capture. That means they just get it and they put in a box. And that's it. Okay. So the attacker tried to do an injection on a PLC. It doesn't receive any answer. Of course, then at some point it will give up, and there is no physical interaction. That is and this is, I think, this is one of the best paper around that we have. So actually, most of those frameworks, what they care is to emulate PLC from the point of view of fingerprinting. When you are scanned by tools, like there are several tools. There are also tools ad hoc for PLC, okay, NMAP, P0F. There are also PLC scanner. There are specific tools for PLC, and in order to return a profile that looks like, it looks like a PLC. But then it's so. In order to build the point is that there are a number of issues in order to be realistic, convincing honeypots. First point is that you don't build up just a PLC out of nothing. If you want to appear as an industrial control system, you must have a network with hundreds of PLCs around. And that looks more realistic. So first of all, there are not many, corporate allow this, there are not many that allow a network-oriented honeypot framework. There is no really, I have not seen really an implementation. I would like to see, I will be really interested in reading a paper by Russo. I'm not seeing any really module that really does an implementation of the physical process in such a way that when the malware do an injection, it's just not a passive capture, it's an active one. So you execute in your simulated environment, and that's really what we would like to do.
1 minute left for your presentation.
Yes,
sorry, but we are a bit
in order to, because this is important, in order to have a realistic response time. Because this is an example, if you don't answer in time, the attacker doesn't get into it. So our project is this, our research project, and this is basically, Marco PhD work in writing down, a framework where you can you have these features, you know, PSC, personality simulation, physical process simulation, ladder logic, injection capture, and also safe execution of this, of the injection, in order to give an impression to the attacker that you really did what he asked, and not just a matter of introducing the layer. That's it. Thank you.
Thank you, Massimo. Thank you for your presentation. Very clear. Any quick question?
I have a very quick question, if it's possible.
Sure.
Yes.
Hello, I'm Andrea Melis from University of Bologna. And so the fact that a honeypot needs to be to look real, it means that you need also to continuously improve and modify the behavior of the honeypot according to what the attacker check in order to do anti-VM evasion, for example, or in this case, anti-honeypot evasion.
Mm-hmm.
So there is a continuously improvement. And are you planning to study also this kind of topic, or you just want to have like a release of one?
Andrea, we are just at the beginning of the project, you know.
Yeah, okay.
So Marco just started in October his PhD, but at the end, yeah, we would like to do that. But for the moment, we are just adding a physical module that reacts to it, and we are starting from sample physical process, you know, like, you know, a water tank. You know, you have a pump, you have sensor of the level, and you put you move a bit the pump, you switch on the pump, and you want to see the water coming. Again, you know, this is a quite easily simulated with differential equation of this kind. And then, of course, then you have to keep going with the attack. It's not just a matter that it does something, and then you're done. Okay. I don't know if this answers your questions.
Yeah, definitely. It means that I'm gonna follow your work in order to see the improvement. Definitely.
Yeah,
thank you very much.
That's a 3 years research project. Hopefully, we get something.
Thank you.
Thank you. Thank you, Massimo.
Thank you for your question.
Thank you again. So we can move forward to the last presentation of this session. And this presentation is from Politecnico di Torino, and is about Pyrothesis. So the author will describe their experience in creating an hybrid cyber range. So we have Gianluca Roascio.
Hello, everyone. Can you hear me?
The floor to you. Yes, we can hear you, and we can see your slide.
Okay. So good morning, everyone. I'm going to present our work here in Politecnico di Torino, which is called Pyrothesis. Okay. This is a project for a hybrid cyber range that includes the most impactful part is the fact that this cyber range includes physical devices. Okay. So Pyrothesis, why we choose this word? Because it is a Greek word. Okay, it is the Greek word that indicated the education, and also for extension, also the place where it took place. It is, as I said, a hybrid cyber range in the sense that the most of the services for connecting, for exploiting the scenarios that are inside this cyber range are virtual, but with the target that are physical devices. What physical devices? A type of physical devices that maybe is somehow not completely supported by the rest of the cyber ranges. We have embedded devices, microcontrollers, FPGAs, specialized kit also to make side channel attacks and fault attacks, so also physical attacks. Okay, other network hardware like switches, firewall, routers, and so on. So the challenge, what is the challenge of Pyrothesis? Making all this stuff, okay, capable to host challenges in Jeopardy or attack defense, if we talk about capture the flag, for example, but also exercise in terms of acquiring the experience to program these devices. So this is the challenge: make these devices available from remote. Okay. The cyber range is physically hosted here where I am now, okay, in Links Foundation in Torino. Okay, I don't have to present you most what is Hybrid CyberRange. I think many of you already know. Okay, Hybrid CyberRange have conjugated the best, okay, of physical cyber ranges and hybrid, and virtual cyber ranges, in the sense that we have the flexibility and the scalability that is available for virtual cyber ranges, but with the realism of using real physical devices, okay, that are present in our infrastructure, okay? Everything is managed by virtual machines and virtual networks, okay? So through the construction, okay, the building up of these virtual networks, we ensure, okay, also the correct isolation between devices, okay? The hardware components are the real targets, okay, of this scenario. They contain the vulnerabilities that are to be found and exploited or patched, depending on what is the exercise. If an attack exercise or a defense exercise, could be also both of them. These are the building blocks of Pideusis, okay? What constitutes in its basis Pideusis? We have the component that are every physical or virtual pieces that compose up Pideusis. The components are grouped into subnets, okay? Subnets are a set of components that are directly interfaces with a virtual or physical interfaces. One or more subnet can build up a theater or a range. What we call a theater is something that is up to host the scene, okay? That is available to host the scene, the particular scene, which we call scenario. The scenario is the particular setting of the theater able to host a particular storytelling or a specific exercise. What are the ranges and so the devices that are hosted inside Pideusis? In the right, you can see a schematic. Okay, we have as we said, microcontrollers, FPGA, devices that are called chip whisperer that are targeting physical attacks, so side channel fault attack, network devices, industrial control system, Internet of Things, many of these particular devices that I will go also in detail now, okay? And this is the list, as you can see, of the thematic ranges that are hosted inside Pideusis. The architecture is more or less like this one that you can see on the right, okay? We have two kinds of accessing the architecture. Of course, there is the user services, okay? The one that consent people to access the exercise, okay? From the other side, there are the maintainer services, which are instead accessed by the green team, the white team, the people that are supposed to monitor the activities, to set up the scenario for other users and so on, okay? So these are I represented as two virtual servers, okay? Behind these, of course, you have machines, okay, dedicated server for each cluster of device that can be, that has to be offered to the external, okay? So for example, if we have a cluster of similar devices, they are all behind the same physical machine that is responsible for hosting them, okay? So every device inside the architecture, of course, is protected with the virtual network rules. So the devices are only visible to the people that are correctly authenticated and put into the virtual scenario that we create, okay? And of course, they are configured just to include the intended functionality. Of course, we don't want to make people exploit things that we don't know they are inside the device. So we exclude everything from the building when we set up the scenario. Management and orchestration, we use to make up every scenario using virtual machines, okay? Both in the case you connect to a physical device or a virtual device, in any case, you always connect to a virtual machine, okay? To manage all these virtual machines, we use a tool that is called Proxmox, okay? To virtualize the network, instead we use WireGuard. So through the WireGuard, you have to just import a configuration on WireGuard, and you just see when you enter your scenario, you just see a network that comprehends only your devices. Even if they are physical, there is no possibility to reach other devices out of the scenario. We are investigating about the use of Tosca. Okay, Tosca is a scenario definition language. Okay, that already supports. It is a standard. Already supports the creation of completely virtual environments. Okay, we are trying to adapt this, and we are succeeding in this. We are using Tosca to have also hardware device supported. Okay, the final idea is to have, of course, a library of configuration file that the maintainer services can access and set up to make the scenario available. The secure programming range, okay, this is a device that hosts inside a microcontroller, FPGA, and smart card. It is a 3D chip, okay? What is the purpose of this range? Learning to program, okay? People connect to a virtual machine, the virtual machine is connected to the device, and people learn how to use it, how to program it, okay? For the moment, this is the principal usage, but no one excludes that in the future, also challenges, also CTF challenges are hosted inside these devices, for example, for an interaction in command line or in also in graphical way. Okay, so for the moment we have virtual machines that are remote desktops. Okay, with all the necessary tool to program this device. Okay, which is a specific chip for the security. Okay, as you can see from the components. This is a photo that I take. Okay, that I took in the range. Okay, these are the devices that are connected to the server that is exposed outside. Hardware security ranges. Yes, these ranges are intended to offer the possibility of both learning to program and also challenges in a field that is not that, let's say, not that investigated in the other cyber ranges, because we want also to introduce, and we wrote also a paper on this that I will present tomorrow. We want to introduce in the main CTF competitions also the possibility to have challenges that are related to the hardware design itself. Okay, so for example, vulnerability that is inside a VHDL file and you have to exploit it. Okay, or for example, a CTF that is based on a fault attack or on a side channel attack. All these things are not that, let's say, supported from the panorama that we have today. So we want to insert into this. Okay. Network security range. This is a range that we used for the last final competition of Cyber Challenge. Okay, we have a bench of we had a bench of Wi-Fi routers. Okay, every participant has to first exploit his Wi-Fi router and then exploit the one of all the others. So it was a quite different challenge from what the people are used to, but it was a very good experiment. Okay, we managed to have it very well, and so in this case you can exploit all the vulnerabilities that can be also in a physical component like a Wi-Fi router. Okay, this is a photo, okay, of the range after the setup before the final day. Okay, industrial control system range. We also have an infrastructure that emulates a real aqueduct. Okay, the challenge here is to transform it into a cyber range. Okay, so for example, to introduce vulnerabilities that are in the communication devices. Okay, in the SCADA, in the Modbus, in the sensor and actuator that communicate through the Wi-Fi or in Modbus. Okay. So this is the challenge. At the moment, we just have an idea, okay, or to set up, but the infrastructure is there. Okay, we have the emulator of the aqueduct. We are extending it to support a cyber range. Okay, Other IoT-based range, okay, we have, for example, networks that emulate a smart building, in which we collaborate also with the Sparta project of the European Union. Smart city, okay, so possibility to have devices such as surveillance cameras, air quality sensors, and others, okay, so ranges that emulates such an environment with specific challenges maybe, okay. So here the goal could be challenge and training as usual, but also research, because, for example, you can investigate on your solution for security of IoT, and you can test, because this is a realistic test bed in which you can test your solution, okay? Okay, I'm done. Just a conclusion. Two things. ITASEC want to add something, okay? We don't want to emulate someone else. We want to make something new, okay? So we are setting up all this because we want to address a specific part of the cybersecurity which is maybe not mainstream, let's say like this, okay? And we strongly believe that hardware and IoT are very important nowadays. And so also the security of IoT and hardware is very, very important, okay? Strategic, as I defined here. And of course, ITASEC wants to be open, okay? If I dream, ITASEC hosts, okay, many ideas from the community that may come, and we can adapt ITASEC to host also ideas related to the world of IoT and hardware that come from the community, okay? I'm waiting for your question. Thank you very much for the attention.
Thank you, Gianluca. Thank you also for considering Toscan and STL in your solution. So any question from the audience?
Yeah, I have a question, Enrico. May I?
Yes.
Yes.
Well, thanks, Gianluca, for your nice talk. Just something what you emphasize, of course, is the realism, meaning that you use real physical device, in your CyberRange, of course.
Yes.
That's, of course, give you a realistic answer because you. But I'm wondering whether the problem about the scalability. So you can manage with, I suppose, a small number of devices.
Of course, this is an issue. Of course, this is an issue, is an open issue. Okay, the challenge is have the, let's say, virtual infrastructure in such a way that extending the number of devices is not a problem, okay? Because, of course, if you want to support 100 physical devices, you have to install, okay? This is no way out. But the challenge is, okay, this is for sure to be done, but at least let's try to have the virtual environment prepared to be easily scalable in such a way to support the connection, okay? And in this sense, we are trying to arrange, okay, with several solutions that are going to be much more experienced with the time, but at least, of course, we are trying to set up at least the, let's say, support hardware and the support software in such a way that, okay, when I want to add something, I can with no much problem. Okay.
Thank you.
Thank you, Gianluca. So I think we can conclude this session. And thank you again to all the authors and speakers. And so I think we can move forward to the third session with Gabriele Costa.
Yeah, thank you, Enrico. So let's start immediately the next session, since we are slightly late with respect to our original program, not much actually. So I would kindly invite the next speaker, Mauro Andreolini, to start sharing his slides. And Mauro, for you and also for the other speakers, I will alert you when you have only 1 minute left. Okay. Is Mauro here?
Hello, can you hear me? Hello?
Yeah, hello. Hi, Mauro.
Hello? Can you see me?
Yes.
Yes. Perfect. Can you see the presentation?
Yeah.
Yeah. Thank you. So I will start briefly. Sorry for the delay. we had a rough morning trying to adapt to the new environment. So thank you everyone for joining us. And this is a presentation on CyberRange. And let me first thank all my students and co-workers who made this demo possible. And what is the CyberRange? CyberRange is a pre-arranged virtual environment offering realistic attack and defense scenarios. Training goals are manifold. And offer the opportunity to teach penetration testing, teach defensive techniques, exercise readiness and cyber awareness, and aid in vulnerability research and asset validation. Typically, the most popular scenario of a CyberRange is a red team versus blue team exercise. In this presentation, we are going to talk about trainees and trainers. Who is a trainee? A trainee is a participant to an exercise. He is subject to an evaluation process. And a trainer prepares the exercise scenario, defines a training goal, an evaluation process, and monitors trainees' performance during the exercise. This is going to be our subject. How does trainee evaluation take place? CyberRange is usually equipped with a scoring system that evaluates trainees' performance. Typically, the scoring system is a web-based dashboard that updates in real time. What are the inputs to a scoring system? For example, for a red team or versus blue team exercise. These are the inputs. Is a host down or up? Is a TCP/IP service down or up? Are applications not working, partially working, fully working? With these inputs, a score is computed. An example dashboard, assuming the Lockheed Shields exercise, has on the rows, the different trainee teams participating. In the columns, the different goals, and if you cross a goal with a team, you see the score for that team. It tells you how bad or how well it is behaving. What are the limitations of goal-based performance measurements? There are some limitations. There is no focus on the actual activities performed by trainees. We are failing, but we don't know why and how. Can we do better than that? This work is actually taken from a paper we published last year. The research contributions of this paper were the following. So we define a model of trainee activity through directed graphs, which are built from collected live data. We propose several scoring functions. We will actually see only once due to lack of time. And these functions model specific abilities of the trainee: speed, precision, and the ability to discover new flaws. We will see the precision score. We also propose a modular framework to collect the user activities and compute and update these graphs and scores during a live exercise. We will also show a video demo. We use reference graphs. What is a reference graph? A reference graph is a graph. It has dummy nodes, starting and ending nodes. We signal the start and the end of activities. They really do not represent anything besides beginning and end. This graph has vertices. The vertices represent intermediate goals. Okay? Here we have a sample reference graph, which is for a very simple web-based activity. We have a login bypass. We have substantially a dump, and we submit a flag per server. Three intermediate simple states. These are modeled to nodes. This graph has also edges. These edges represent actions done by the trainee and are labeled with the event type, which can be a web request or a Unix command or a PowerShell Windows command. And we also record the actual command given or the actual error given and the status of the command. Okay? The trainee graph is substantially similar to a reference graph. It is conceptually similar. It is built online from collected data and tries to mimic the performance of the trainee during the exercise. Differently from the reference graph, When a trainee, a user, a player does not follow an action which is supposed to take him to the next state, the trainee graph is augmented with a dummy node shown in red here in this slide. And actually, there's a name derived from the desired state. For example, here, you would, when you are in the login bypass state and you want to see, you want to reach the flat page reached state, when you fail doing this, because you probably use a bad rule, you're ending up in a state which has the same name with an ending R. Okay, error. So what happens? We connect all the actions done by a trainee, and we also collect all the bad states a trainee is entering into. So we are able to tell why a player is failing. To reduce noise, we implement for each of these intermediate nodes blacklists and whitelists of command. For example, we omit the commands cd, help, and man. We don't use them to build reference graphs because they will be too noisy, there will be too many mistakes. Of course, you can include them if you want, but we found that it is often more practical to avoid them. And we also build whitelists of commands that make sure that if an output has a given value, then we bring it from a state to the next. So we can track pretty efficiently passage from an intermediate state to the next, or an error, okay? We also monitor the position of the trainees in the exercise and also the timestamp when the trainee finishes an exercise. What is a scoring algorithm? A score is a function that takes ideally n graphs, at least a reference graph and a trainee graph, compares them somehow, and outputs a real number, typically in the 0-1 range. So let's see an example score. The learning objective is for the student, for the trainee to reproduce faithfully an attacking technique. So the evaluation criteria is to measure how much a trainee diverges from the correct sequence of intermediate states and the correct sequence of actions. To do this, we introduce the symmetric difference. Given two sets A and B, the symmetric difference is A minus B, all the elements in A minus the elements in B, union all the elements in B minus the elements in A. If A and B are equal, the symmetric difference is the empty set. If A and B are disjoint, the symmetric difference equals the union of two sets. So the idea is to compute symmetric differences on two sets. The vertices of the reference and trainee graphs and the edges of the reference and trainee graphs. With this idea in mind, we define a trainee graph, GU equals VU, EU, and the reference graph, GR, equals VR, ER. So V are vertices and E are edges. We define efficacy as 1 minus the cardinality of the symmetric difference between VU and VR. And we divide this one by the cardinality of the union of VR, VU and VR. So why this? If, as we saw in the previous slide, if the sets are equal, the difference is the empty set. So this value is null, and the efficacy is 1. On the other hand, if these two sets are completely disjoint, what does this mean? This means that the player is even able to reach one state. These two sets coincide, these two values coincide. So we have 1 here, and 1 minus 1 is 0. Some intermediate produces a value in 0, 1. And the same thing holds for the edges. The only difference is that here we are reasoning in terms of intermediate states, and here we're reasoning in terms of actions. So we are effectively checking how close to the intermediate states the player is adhering, and how close to the actions, the commands, the intermediate player is adhering. This is efficiency. It has the same semantics as the efficacy. The score is an average, weighted average with a parameter alpha. In the paper and in this demo, alpha equals 1/2. But you can tune this to give more weight, more importance to following commands, or more importance to adhering to the correct intermediate states. This is our architecture. We have several lab machines. These machines collect input and output logs of Unix command and PowerShell Windows commands, and also URLs of formal firefox. These are taken through 5-bit and sent to an Elasticsearch cluster. Here, a controller, the lab server, periodically queries the Elasticsearch cluster and retrieves information data and computes the trainee graphs and scores and updates them. These can be viewed through a Kibana dashboard, and the operators can input new reference graphs and retrieve trainee graphs through another Python-based interface. So, demo time, I hope you can see this video. Okay, so here we are. On the left, a trainee which is trying to call the Jotmix 1.1 machine. This is a very simple web-based machine. On the right, we have the scores. We have several scores and several aggregations of scores. We won't talk about this in the start for reasons of time, but I suggest you check out the S3 score, the evolution of the S3 score. This is the score that we have been talking about. Here, on the far right, we have the trainee graph updated in real time. So let me speed up the video. Okay, so we have this very experienced, skilled penetration tester who's trying to get RCE after a simple injection, and then trying to become root by applying an exploit. You see, he's making some mistakes on the way, so it's very hard to get a perfect one, even for an experienced tester, but in the end, he manages.
Mauro,
okay, he manages to get through. So let me check the other video. I guess you got the idea. And okay. So here you have the other player demo. Okay. Okay. Let me quickly show you the mistakes he's making. Okay. So we are happy to follow the mistakes of the player, and we know where he's faltering, where he's failing, and why. So coming back to the presentation, and I'm continuing this. These are the scores. The better player performed 3 times better than the average player. These are other scores. The interested reader can read the paper and see what they are doing. These are the training graphs, so we can see that the first player is failing at the simple injection and at the RCE, and also how. So in future work, we try to explore new aggregations, work on the defensive side. This is only something we have been approaching right now, and releasing the project on GitHub. So everyone who's interested can read the paper and ask me some questions. So this concludes my presentation. Thank you for listening.
Okay, thank you very much.
I'll be glad to answer them.
Also for being so kind. So are there any questions? Okay, if there are no questions, very quick one. I think your system my question is to what extent graphs
I can't physically hear you. The audio is dropping. So if you could write the question somewhere in the chat, I can answer it. Sorry about that.
Okay, so I can ask much time. Thank you so much.
Thank you. Okay.
So what is
Questa è la presentazione.
Yeah, Mauro, can you?
Yeah, I'm trying to understand how.
Thank you.
I will immediately do this. Sorry about the delay. Possiamo aprire la finestra proprio. Questo qua? Intanto proprio esci, chiudi la finestra proprio. Chiudi proprio le braccia così, guarda. We will do this immediately. Sorry about that. No, presentalo, esci proprio, se no usci, filla proprio. Tanto è finita. Dopo lo faccio. Ok.
Ok.
C'è un audio pazzesco.
No, Mauro, we can still hear you.
Oh.
Okay, now you're muted. Thank you very much. Okay, so our next speaker is Angelo Spognardi. That should be already connected, Angelo. I can see you.
Yes, I'm here. Can you hear me? Can you hear me properly?
Yeah, perfectly. And Angelo is going to present us CyRCall, a CyberRange for continuous learning. So again, Angelo, I will tell you when you have 1 minute left. Okay, thank you very much.
Okay, thank you. Okay, so my name is Angelo Spognardi. I'm associate professor at the Dipartimento Informatica Sapienza in Rome, and so working with CyberRange is something that I started to do while involving one of the projects that was mentioned several times during this morning of CyberRange activity. So it's Unavox in our big project, and was a very, very interesting project to conduct. And within this context, I worked with one of my students, Bassetti, Enrico Bassetti, that now is a PhD in our department. And so we tried to see something that was in some way providing some novelty in the context of the CyberRange. So we're trying to see what's missing in the landscape of CyberRange, and we come up with this solution. It is, I hope that it will be in some way interesting for all of you. So this will be the roadmap. So just a brief introduction, just to give the proper name that we will introduce, that we'll see in the presentation. I will show you the state of the art, so where we started from in some point. Then we start to describe the idea of our continuous learning approach to the CyberRange, and some of the design and challenges that we found in this implementation for this idea of the continuous learning CyberRange. So this is just to see the definitions. I will be really quick on this. Sorry, I will be very quick on this. What is actually a training camp? So it's some way a place where there are some rules, and there is a period of training where people learn by doing something. Okay. So now the point is that it's a particular space, a place where you have to go and do something. Okay. So this is just a picture of what is a training camp in the classical details. But actually, this is another one, and as you can observe here, we can see some of the actors that play in the context of the CyberRanges. So who is important to see that they are the trainee and the trainer. Okay, we have roles. The roles that we have in the CyberRange can be defined with colors, usually in the terminology. So we have the blue team, that is actually the defender, the red team, who is the attacker, and then and this is something that maybe sometimes is overlooked, is the yellow team, that are the other players. So in the context of the the classical definition of the CyberRange, the training range that we have seen before, for example, they could be civilians, or they can be people, they can be reporters that are, during, for example, a military battle, something like this, that is, simulated. So it's people that is involved in the activities, even if they are not the starting, but they are there and they do something during the simulation. Okay. In addition to them, we also have some additional roles, additional teams that are the green team and the white team. So the green team is the one that in some way manages this special place in order to define the timing, and also can in some way interact to provide some additional tasks to the teams. They can also check that everything is working properly. And then we have the white team. So they can be like, the referee that in some way they are involved to give an evaluation and to maybe collect the results. I can also try to see at the very end who was the winner between the participants. When we move to the cyber training range, so we can see the one of the examples that we played with. So it is one of the pictures that we had at the Unavox during our first meeting in Chiavari. We were actually doing a simulation of a real, let's say, a real exercise. No, we had some students. And one of these was actually Enrico that was working in the blue team of Unavox. And we were trying to, in some way, train and to test this CyberRange, okay? So at the very core of a CyberRange, what we have, that usually there is a virtual training environment. We have remote training or maybe local training that work together. And we have a scenario where usually the action is taking place. But if we really want to go and have a look on the category, so this is something that was also really nicely expressed in the first presentation that we had, where there was Nina presenting this survey of the type of cyber ranges that we have. We can distinguish between two different kind of simulations. So we have the event-based and the scenario-based simulation. In the event-based is something like, Local Shield, Unavox, so where there is an event with a start and a stop, and the event happens between this time. So it's a very limited period of time where we have the CyberRange activity, okay? We don't really consider, what actually happens before, because we have seen that it's, the most time-consuming action. Then, in addition to this, and this is one that we focus on in this particular work, we also focus on the scenario-based, where we have, something like games or like structures, where we have episodes. So yeah, the single user can connect and can play in the scenario, like capture the flag, or maybe playing some activities, try to exploit something. And the idea is that this kind of scenario, and we actually revised many, we have collected many of these examples, also in the literature. The idea is that they are not really limited in time, but they are really focused on something. Now, if we ask what actually is missing here, in this exercise, this type of exercise that we have, is that what actually is missing is the reality. Okay, so the idea is that we know that the users go there and have to play with something. So they have to be they have to undergo a simulation. Okay, so there is not really the feeling that is something that is happening and can happen continually. Okay, then I want to just show you where we started from. We started from my class on practical network defense that we have here in Sapienza for the cybersecurity activity. We try to build a network topology where our students can play with, and they have to configure from scratch all the security elements for protecting a real network. So the idea is that we have small teams of 2-3 people that receive Acme network like this. They have to work with, VPN. They have to work with intrusion detection system, log management, firewall rules, and stuff like that. So all of them have this picture of what's happening in the network, so they can move from one machine to the other machine just to properly configure what actually is needed to properly configure. So we started from a real, let's say, environment that we can get some inspiration. In addition to this, we analyzed some 12, okay, 12, this is just a number that was, you know, when we started our activity, try to understand the different features for each of them. And they were really nice for getting inspired on what to insert, like, you know, type of attacks that you want to introduce, some of activities that you want to test with. But at the very end, with considering all these cyber ranges that we explored, something was missing, okay? What actually was missing was the realistic, the reality, okay? And also the, you know, the evolution, okay? So at the very end, what we have is that cyber ranges that are very well done are made by humans. So they are really, like lock and shield or all the other activities, are static. And the simulation is limited on a period of time, okay? Yes, you can see that because it's a very time consuming, so you have to do full time dedication for, because it's a very complex, but we want to do something different, okay? And also we want to do something that is more similar, closer to a game, okay? Something like that you really want to play. So without that feeling of, you know, depression, because you are, when you work on, you know, lock and shield, you are under pressure because there are so many things that you have to do at all, and it's like full-time activity, okay? So maybe it's not that much fun. The idea was to have something, a cyber range that was also engaging, like a game that you want to play. So if you want to think about it, it's something like having a Tamagotchi, okay? So this is the idea. So we want to have a cyber range where the user want to play, where the scenario evolves, okay? And actually you can play with the your knowledge. And so when you learn to do something, the cyber range in some way evolves because you become smarter and introduces some additional tricks, additional machines that you have to protect, or maybe, you know, some additional elements that can not only make the scenario evolving, but also can engage you even more in what you do, okay? So this is the idea. We want to have, we are proposing to have this idea of an evolving scenario and with the resource, some resource limitation. And the idea is that you can evolve your scenario also because of your actions. So the idea is that if you become smarter, so if you are able to protect your network, so you gain some credits that you can spend, for example, for additional equipment. And then you can build an additional firewall, or maybe you can I don't know, have an extra section of the network, stuff like that. Okay, so you can change your network because actually you become smarter. Okay, so the idea is this: you start with like a defender, because actually this is was mainly focused on the defending side. You start with a virtual budget that is limited, and then this virtual budget increases as you are able to defend your cyber range. Okay, so you progress in the game, so in the cyber range, and then you gain so you unlock some of the features of the cyber range, like, you know, extra equipment, or maybe, and this is actually something that I expose you. So the simulation is open-ended because actually we can imagine that the simulation, so the cyber range never ends, because actually we can imagine to have this cyber range to continually evolve. And this is the idea that you get, so the user get engaged, so it becomes its own network, okay, like a game that he wants to play, okay? And there is another interesting thing that we were imagining. Sorry, I was to see here. That is the idea of having, keeping in mind this essay. So a chain is no stronger than its weakest link. So the idea is that who is the weakest link in our cyber range? We've seen that we have the blue team, but actually, oh, 1 minute. Okay, so the idea is that we want to also use the yellow team as one of the players. Okay, so the idea is that you can also spend your virtual budget also to train your yellow team. So the yellow team is the one that downloads a malware, or maybe make a mistake in the programming, can leak, or can have a buffer overflow, maybe can program something that is exploitable, then you can train your yellow team in order to reduce and to improve its own capability of defending your, so not doing stupid things. Okay, the idea was to have, a red team automated and also white team automation so that you can, evolve the team. We have several implementation challenges. So now we are working on Proxmox, that was one that was mentioned also before, where we have real virtual machines, but also container. These can help to have, really many different scenarios working on together. And the challenges are the idea of the having, multiple VLAN working on top of the other. So I don't know how many of you are aware of this, but, virtual accessible LAN is the solution that we are looking for. Future work, so full automate all of our teams in our scenario. Also imagine to have a group play where several students can use it. Okay, several participants can join together to the same group and can, take care of each of the different sections, or also one against the other, and also support information exchange if you can imagine to have different CyberRange running at the same time. They can exchange also information. Sorry, I had to rush up at the end. I was a bit slow in the presentation, but thank you for listening. And if you have any questions, I'm here.
Thank you very much, Angelo. And so are there any questions from the audience? Okay, so I have a question, actually, a very quick one, Angelo.
Yes.
So you have shown with us that Linux containers are probably the most promising technology for solving these huge demand of resources of a real cyber range, which is something I totally agree on. Mm-hmm. But you also mentioned in your motivations that you wanted to go for high degree of realism and also for having simulations that evolve according to actions of the participants. Can you tell us something more about which kind of technology you have in mind for implementing this kind of behavior, which is totally non-trivial, is beyond emulation?
Yes, it's the idea was to so this is one of the things that we started with Unavox, where we are working on this idea of having a way to monitor the activities of the users inside the cyber range. So we were imagining that when you have several machines that are your let's say mission objective, so you have to protect these machines. As the network builder, you know that there are some vulnerabilities, so you know where you have to look for. And then the idea was that once we have the defender that was, for example, patching this idea, or maybe when, for example, 3 times the attack that we were conducting was failing in 3 times in a row, then you can decide this was like acquired, and then we can think to add an additional machine, like a new objective in the network. So this is more or less the idea.
Okay. So you have a sort of storyline behind the
yes.
The training activity itself.
Yes, this is one of the ideas, so that you have a storyline for the single machines. But the idea is that we want to have something like a set of possible evolutions, okay, that can also be randomly done. Okay, so you can also randomly add additional machines. But at the very beginning, if you want to, in some way, think that, okay, this lesson was acquired, then you, for each machine that you add, you have to think about the exploit that has to be patched in order to, acquire the point.
Okay, thank you very much, Angelo. Very, very interesting again. So let's move to the next speaker, who is Andrea Melis. I already see you, Andrea. Can you hear me?
Yes, can you hear me?
Yeah.
I'll share my screen. Okay.
So Andrea is going to present us his work about digital twin for industrial IoT networking. As usual, I will alert you when you have 1 minute left. Okay?
Thank you. Thank you. Oh, come on. Okay, everybody can see my screen, right?
Yes.
Okay. Good morning, everybody. I'm Andrea Melis. I'm a postdoc at the University of Bologna, a member of the Ulisse Laboratory of Information Security Systems. And in this presentation, I'm gonna try to show you the first results of our ongoing project, which is related to the CyberRange about digital twins for industrial IoT networking. So this work is part, as I said, of a regional government project of Emilia-Romagna government, which is called I4S and stands for Industria Sicura 4.0, Security Industry. I don't know exactly how to translate it in English. And we are part of a consortium which includes another university, the University of Modena and Reggio Emilia, which is the coordinator of such project. And we are glad to be part of also of a network of companies and research lab, which in particular gave us the use case, real world use case that are the basis of our first results. So the main goal of such project is, of course, to create a CyberRange and a digital twin, which is an environment where the company can test both from a safety and a security point of view, solution protocols or also applications. I think that the difference between the previous really interesting work is that we focus our goal in terms of the infrastructure. We wanted to be able to create a solution that can create and in particular automatize the creation of a solid virtual infrastructure that can emulate a production plant, for example. And I think that this kind of automation is important. It's also been pointed out by the Leonardo talk on the beginning of this morning. And thanks to some of virtualization technology, we are able to recreate such infrastructure. So the objective, of course, is to create a solution that makes it's a CyberRange, which means a safe environment where we can work on without worries of to make big damages, and a digital twin, which is a digital copy of the real world use case, the scenario of a company, of an industrial network, etc. On top of that, so we are starting. This is the work in progress part, where we are trying to simulate some security solution and to propose also some automatization on the test, for example, of industrial protocols such Modbus. So the technologies that allowed us to implement such solution are mainly two. Thanks to our background, which is we have a good background on software-defined networking and network function visualization. We used an ETSI management orchestration, which is called Mano, open source Mano. It's composed of two main important blocks: the descriptor of a network component, which can be a device, a switch, or whatever, and the behavior, how they interact among each other. So the description of the network. So thanks to these two main building blocks, we are able to easily recreate in industrial infrastructure. So this is, for example, the basis, the reference architecture that the companies gave us. They have, of course, a production plant behind what can we see on an IoT connectivity, behind a DMZ, for example, etc. And there is an exit point, a gateway that collect other section of the network, which can be a public network or another section of the industrial network fulfilled with firewalls, VPNs, and IDS. We are trying to recreate or we create the digital twin in this part of a typical industrial architecture, and we try to follow the digital twin life cycle, which is called digital twin life cycle, inspired by the network slicing concept, where we first define what are the main component. There is a preparation step where we define all the device component and all the networks and the interconnection among them. Then we create such digital twin, and we enter in the life cycle of the network slice because it's separated from the other, and there is all the test, activation and deactivation phase in such part. So the two main software that we used to create our project, our CyberRange project, are, as I said, Open Source Mano and OpenStack. OpenStack, of course, everybody knows it. It's a virtual infrastructure management or virtual infrastructure provider. It's the instrument that allows us to deploy a virtualized component, a VM or a container, etc. And in top of that, we added an orchestrator of NFV, which allowed us to take as an input the description of the device of the network and deploy it automatically on a cloud computer, on a server through OpenStack. So the integration among these two components is the key of our digital twin solution. So as I said, we have two main components, two main building blocks, the VNF descriptor and the NS descriptor. One define an item of the network, and the NS descriptor is the way how they are connected. And of course, there is also the image repository, which represent the image of the device that we want to deploy on. And this is important because we can also take as an input a company image repository of a specific protocol or whatsoever, or a specific also attack or scenario that they want to test. Just the important is that we can use it in our orchestrator as every other image. So it's that there are two separate layers, let's say. The component that we are trying to emulate include both monitoring and security components, such as the packet inspector, IDS and IPS component, VPN servers, traffic shaper, traffic monitoring at a low level, for example, on the data plane level, firewall. And on the other side, we're also starting to replicate the application behavior of a typical industrial company, because this is the work in progress part, because now we are, let's say, good with infrastructure emulation, but there is also needs to emulate all the application part with protocol simulator and service orchestration, for example. The current deployment that we created according to the use case that we received from our industrial partners is this one. We create, let's say, four different network that represent the way how we can interact with such deployment. The management line, the corporate line, and the line where all the industrial protocol are located. And it's important that here that we follow what the company says. There should be 3 zones of field zone that represent all the industrial application part. The operational one where for example, the IDS and the packet mirroring is performed, and then corporate firewall. In this way, following this INC model, we're able to simulate attack on different levels from an external component. For example, if we go through the internet connection, internet network, or even from an insider threat point of view, because the attacker is linked directly to the operational network. Right now, from a security perspective, we are testing two main things. First, it's trying to automatize some attacks from the specific industrial protocol, mainly Modbus, MQTT, or can open. And another field right now, thanks to the T3 lab collaboration, we are trying to test some IDS rules, and in particular, we are trying to study how we can automatically generate IDS rules from the CAN bus, can open description of the application. So that's time for a short demo, since I don't want to bother too much the god of demos. I prepared a small video that I aim to show a little bit of our infrastructure. So first of all, let's see the GUI, the main page of Open Source Mano. Once you open the first thing that we may need to do once you open the management console is to link the Open Source Mano to an OpenStack instance. So you need to have, of course, the virtual infrastructure provider in order to deploy the infrastructure. And the good point in this case is that, of course, you can have more than one and choose which one use it. This means that scalability, in this case, it's kind of just a terms of add another OpenStack instance. As I said, the cool part of Open Source Mano is that you can define from of course, a simple file descriptor, which in this case it's a YAML, but it can be another file description format, JSON or whatever. You can define what is a network item in the network and the description of such connection. So the VNF represent a virtual machine, can represent a switch, can represent every other items, and as I said, it's a simple YAML description, perfect for the infrastructure as a service paradigm, because of course now we have a GUI which is fancy, okay, and it helps us, the administrator, to deploy such descriptor, but we can script everything because it's everything almost based on REST API connection. So as well for VNF descriptor, also for the NS descriptor, you can you need just to specify the components that are connected to such description, to such NS descriptor. In this case, for example, we have the IDS, the firewall, the management console item, and etc. And then you define the networks with the subnet address and the protocols that link. Sorry?
1 minute left.
Yeah, awesome. Okay, I'm gonna skip a little bit. So the process of deploy such descriptor, as I said, it's really easy. It's a simple drag and drop on the user interface, but it also can be scripted thanks to infrastructure paradigm. And when we want to launch such descriptor, we just choose the correspondent OpenStack node where we want to deploy it, and from the OpenStack management console, you can see that the infrastructure is created with the device and the network and so forth and so on. I have just a couple of seconds, for example, on the work that we are doing on from a security point of view, the testing of the firewall rules. We deployed a small a small example of a Modbus server and a tool which is called Modbus Exploit that can perform such an attack, DOS and CVE taken from internet, of course. And we have a suricata node that hacked as, of course, IDS, and in this case we were testing the IDS rules on such node. On the bottom right, you see the alerts from suricata that pop-ups on every read of the registry, because we are reading the registry. And okay, so I have some other videos, but okay, running out of time. Thank you for your attention. If you have any question, I'm more than happy to answer it.
Okay, thank you very much, Andrea. So questions? So no questions. Since we are getting close to lunch, I would skip the question, Andrea.
Okay.
And invite everybody to make questions offline. And then I would move to the next speaker, the last one. The next speaker is Giacomo Benedetti from University of Genova, I think.
Yes, I'm here.
Giacomo, can you hear me? Fantastic. And Giacomo will present his work about enhancing the crack SDL with mobile security components.
Yes.
As usual, 1 minute left, I will tell you.
Okay. So I just move this away. Okay. As Gabriele said, I'm Giacomo Benedetti. I'm from master student in computer science at the University of Genoa. And as part of my master thesis, we investigated a way to enhance the crack SDL language with mobile security components. So first of all, a little perspective on. Okay. First of all, what is crack? Crack stands for CyberRange Automated Construction Kit, and it is basically a framework for automating the design, model verification, generation, and testing of cyber scenarios. It is based on SDL, the crack scenario definition language, which relies on the Tosca language. So Tosca is an infrastructure as a code language, and it can be used to build IT infrastructures. It is typed, and so all the relationship inside the model relies on the node types. What SDL do is to enable CyberRange specific elements. So for example, here we can see components for vulnerabilities, goals, and specific users. And moreover, SDL works on the interplay of components. Okay, SDL proposes a catalog. So there are some pre-built types that can be reused in order to build from scratch a complex CyberRange scenario. We ask ourselves what do we need in order to create a mobile security scenario. So, for example, if you want to build a bring your own device scenario, we have to take into consideration that employees can access enterprise data and system using their own device. That personal devices can contain out-of-date and so vulnerable applications. That the device owners may be subjected to phishing attacks, and these attacks can come from XMS or other classical telephonic technologies, for example, also calls and so on, in order to deliver a debate. We put these vulnerabilities in order to enable a CyberRange scenario, and we obtain this SDL diagram representing our example. I quickly explain you the example. We have a corporate website and a user. The user has the credential for the website, and it also owns a mobile device. On this mobile device, there is a vulnerable version of Firefox installed. And the red team can now exploit this vulnerable version of Firefox in order to achieve a CV of the last year, 2020, so a recent one, in order to access arbitrary files on the device of the user. So, for example, they can steal the cookie file containing the session cookie for the corporate website. From this example, we highlighted some points. Now we have new elements along with the traditional IT/OT ones. So now we have mobile devices and mobile specific application, also mobile specific vulnerabilities. Moreover, mobile phones are designed as personal devices, so we have to take into consideration the heavy relationship between user and device. So we have to implement in some way the runtime user activities. The mobile phones are only partially controlled by the blue team, unlikely to classical IT/OT scenarios where the blue team has a more heavy impact on the system. And there are also new ways in order to interact with the elements of the scenario. So now we have also SMS, call phones, and so on. So SDL allows us to model standard IT/OT components, but it has not a way to model specific types for mobile components and specific types in order to deploy team toolsets for the mobile interaction. SDL has no declarative specification of runtime injection, and we need to specify user activity in order to be executed during the cyber exercise. And SDL allows components interaction through the specification of the network infrastructure, but we also need the support for mobile-related communication technologies. Again, SMS, phone calls, and telecom generality. For the first point, we added the specific types for the mobile environments. So now in the catalog, there is also a type for mobile system, basically representing the mobile device. There are types for mobile softwares, also known as phone applications. For example, browser, that then later in our example is represented by Firefox. And also mobile users that has some characteristics specific to a user using a mobile phone. The second point, so the runtime injection, we use BPMN workflows. BPMN has the advantage to give us a way to have a standard notation and to specify a sequence of actions through this notation. Then in the framework, each workflow is contained inside a specific SDL workflow type, and the instances of this type are then put in a relationship with the other scenario components, which implements their own actions. At the end, Crack compiles the SD workflow type instances and create a final BPMN workflow that then can be executed against any BPMN engine. So, continuing on our example, if we have to model these two user behaviors, so the first one when the user can log in on the corporate website, and the second one where the user open a link containing the message and navigate towards the website, we can now, for example, take the first BPMN, take its code and put it inside a specific workflow type. The actions of this BPMN are then implemented by the corresponding types. So we have the phone that gives us a way to open an application, in this case Firefox. Then the application gives us a way to navigate toward the website, and the website tells us how to log in into it. All the actions are implemented through Tosca interfaces that are used by the orchestrator in order to operate on nodes and relationships. Now we can instantiate our workflow type, link it, put in a relationship with the types that we previously adding the workflow type of the catalog, we now can reutilize this kind of types in other scenarios similar to this one, or we can modify them in order to gain more types in the workflow branch. For the specific toolsets for mobile interaction, we had to analyze what is the blue team perspective in a mobile scenario. So in a realistic scenario, an IT administrator has not a direct interaction with the mobile device. So it has to control and secure the mobile device using a specific software. For example, a mobile device management software, an MDM. We implemented 2 new types in the SDL catalog using the Headwind MDM, which is an open source and a good MDM. So the blue team now has a view of the MDM, so a web interface where the devices are listed, and they can monitor the status of the application, so if it is installed or not, if it is shown or not, and also the version of the application. Moreover, they can also configure GPS, Wi-Fi, and other devices setting using the provided tools. For the yellow team, needs a way to interact with the mobile devices in order to simulate the user's behavior. So the SDL orchestrator basically generates a specific panel in order to execute the workflow defined in the scenario specification. We use Camunda, which is a BPMN execution engine. Yes. Okay, so let's skip the next. I'm at the end. So for mobile-related communication technologies, we implemented a new type, a mobile hub, which has the goal to register all the mobile devices, to manage the communication among these devices, and to give the red team a tool set, a tool in order to interact with other devices. So also the red team can interact with the mobile hub to reach other devices. It's also useful for the scoring system because for the SLA we can query the mobile hub to have the reachability status of the devices. For the white team, we have a perspective that allows situational awareness directly on the device screen. And so what we have done, basically, we have extended the Crack SDL with the mobile specific component. We have introduced workflow support and specific components for the team toolsets. Moreover, we also have the mobile hub that works as both as a red team tool that management structure. Future work will be to extend for sure the SDL catalog with more mobile-related vulnerabilities and to integrate the crack verification and testing also for the workflows. So I have a little demo, but I think that we had the time, if I'm not wrong.
Okay, thank you very much, Giacomo. Just in case you want to share the demo, if you have a video or something, you can put it in the chat area so that people can
for sure.
Online.
For sure. Thank you.
So thank you very much. We have perhaps time for a very, very quick question. Okay, no question. That's pretty usual since we are very close to lunchtime. Actually, we are on the limit of lunchtime. Thank you again, Giacomo. Thank you all the speakers of this session. Actually, we should have a very quick wrap-up slot now, but I suggest to just quickly thank all the people that attended this session. I think it was a very, very interesting event. This workshop was very, very meaningful to put together the community of people working on CyberRange. I think there's a lot of work that has to be done, and a lot of work that has been already carried out by all the people involved in this workshop. So thank you to the speakers, and thank you to all the people that attended this event. I'm kindly asking Enrico Russo. Enrico, if you want to add something.
Yes, only thank you again for the contribution to all the author and speaker. And thank you a lot.
Okay, thank you, Enrico, and also Franco. So Franco Callegati, if you want to add something.
Franco at lesson, so it's not here now.
Okay, so probably Franco wants to add it's lunchtime.
Okay.
it's pop-up messages, it's lunchtime. Okay, thank you very much to everyone, and stay with us for the other events in ITASEC.
Yeah, thank you for organizing.
Thank you so much.
Thank you.